Yes. So till which topic we discussed in the last class? What was the last topic discussed? Military tanks. Okay. So we are done with blue water navy, right? Amphibious ships I finished. I told you that we do not have amphibious ships. So even though we have Jalashwa, we need NOC from US to use it. So technically we do not have an amphibious ship. So we do not have blue water navy status. So this we discussed. Next is military tanks. So military tanks are combat vehicles used by the army, and we have again 5 generations of military tanks. Okay, the first generation is called light battle tank. First generation is called light battle tank. First generation of military tanks is called light battle tank. The mode of control is manual. Mode of control is manual. And see, there are cannons on the top of these military tanks. So if it is a military tank, I'll show you the video later. There will be cannons at the top of military tanks to fire the weapons. So these cannons need to be rotated to fire it in different directions. But the problem of first generation military tanks is that the cannons are not rotatable or adjustable. So if you want to fire in a particular direction, we have to move the entire military tank in that particular direction. So generally cannons can be moved. Okay, cannons can be rotated. For the first generation military tanks, cannons are not adjustable. So it is not used as a combat vehicle. It is just used as a surveillance vehicle. Okay, so first generation tanks, you can write cannons are cannot be adjusted. Cannons cannot be adjusted. Cannons cannot be adjusted. And we need to turn the entire vehicle. We need to turn the entire vehicle for firing weapons. We need to turn the entire vehicle for firing weapons, which is not feasible in a war situation. Which is not feasible in a war situation. We need to turn the entire vehicle for firing the weapons, which is not feasible in a war situation, and hence it is used only for patrolling and not combating. Hence it is used only for patrolling and not combating. Used for patrolling and not combating. Example of first generation military tank is Sharath. Sharath is an example of first generation military tank. Second generation is called medium battle tank. Second generation is called medium battle tank. So mode of control is semi-automatic. Mode of control is semi-automatic. And it can handle conventional bombs. It can handle conventional bombs. It can handle conventional bombs. And cannons can be adjusted in upside and downside directions. So cannons can be adjusted in upside and downside directions. So two movements are there for cannons. The first generation cannons had no movement. Second generation cannons can be moved upside and downside. So example of second generation is Ajeya. Ajeya is an example of second generation battle tanks. Ajeya is an example of second generation battle tanks. Third generation is called heavy battle tanks. Heavy battle tanks. Mode of control is automatic. Mode of control is automatic. It can handle conventional nuclear bombs, conventional and nuclear bombs, and conventional missiles. Can handle conventional bombs, nuclear bombs, and conventional missiles. Conventional bombs, nuclear bombs, and conventional missiles. The cannons can be rotated in all directions up to 270 degree. Cannons can be rotated in all directions up to 270 degree. 360 degrees not there, up to 270 degree it can be rotated. Example is Vijayanta. Vijayanta. Third generation battle tanks, example is Vijayanta. And the fourth generation is called super heavy battle tanks. Fourth generation is called super heavy battle tanks. Super heavy battle tanks. So it has all features of heavy battle tanks. All features of heavy battle tanks plus some additional features are there. All features of heavy battle tanks plus it can handle all weapons. It can handle all weapons. And cannons are adjustable 360 degree. Cannons can be adjusted 360 degree. So the third generation, I think I told the name as Vijay. And the third generation example is Bhishma. Okay, third generation example is Bhishma. Vijayendra is actually fourth generation. Third generation, Bhishma. Third generation heavy battle tank example is Bhishma. Fourth generation example is Vijayanta. Fourth generation example is Vijayanta. Super heavy battle tanks. It has the features of heavy battle tank plus it can handle all weapons. Cannons can be adjusted 360 degree. Example is Vijayanta. And the fifth generation is called main battle tank. Fifth generation is called main battle tank. It is similar to similar to super heavy battle tanks. Similar to super heavy battle tanks plus some additional features are there. Similar to super heavy battle tanks plus it has shoot and scoot facility. Shoot and scoot. Shoot and scoot. Meaning it can fire while moving. Shoot and scoot means it can fire while moving. It can fire while moving. Then it is amphibious. It is amphibious. means it can operate in normal and wetland. It is amphibious means it can operate in normal and wetland. Then it has a protective shield. It has a protective shield against. It has a protective shield against enemy's weapon called Kanchan armor. It has a protective shield against enemy's weapon called Kanchan armor. Kanchan armor. So example of 5th generation battle tank. First one is Arjun. Arjun is an indigenous 5th generation battle tank. Arjun. So Arjun can actually fire the Nag anti-tank missile, can be fired from Arjun. Arjun can fire it. And then we have a joint development of India and Russia called Karan. So both Karan and Arjun are there. So we have joint development of India and Russia. This is a joint development of India and Russia called Karan. Then India's first unmanned battle tank, Mundra. Mundra is India's first unmanned battle tank. Mundra is India's first unmanned battle tank. And this is basically used for surveillance. It is basically used for surveillance. Mundra. Okay, so these are the different generation of battle tanks. Important battle tanks India is having. So this is a exercise conducted in Ahmednagar, but we can see a lot of military tanks used in this. So as you can see, the cannons with weapons, it is rotated. So these are the major military tanks. Next, we will discuss a couple of artillery. First one is Dhanush Howitzer. Dhanush Howitzer. Couple of weapons we will discuss. First one is Dhanush Howitzer. So you might have heard about the name of this, howitzer. We often use it when some tussle happens between India, Pakistan. The name of howitzer comes in the news. Howitzer is nothing but a short-range gun. Okay, howitzer is a short-range gun, and Dhanush is an indigenous howitzer India is developing. So Dhanush is an indigenous howitzer. Indigenous howitzer. Dhanush is an indigenous howitzer, which is a short range gun. Indigenous howitzer, which is a short range gun. It can fire only conventional weapons. It can fire conventional weapons under low velocity. It can fire conventional weapons under low velocity. So this is the indigenous howitzer. So apart from this, there are some howitzers India possesses, like there is Bofors. Now we have Bofors is a howitzer which we obtained from Sweden. Bofors is there. Then M777 is there. It's a howitzer which we obtained from USA. M777. Then there is K9 Vajra, which is howitzer we obtained from South Korea. So these are the different howitzer we are having. So Bofors, Sweden, M777 from USA, K9 Vajra from South Korea, etc. Howitzers we have obtained from other countries. Dhanush is a howitzer which we are developing by ourselves. Dhanush is a howitzer which we are developing by ourselves. Next is Pinaka rocket launcher. Pinaka rocket launcher. It is a multi-barrel rocket launcher. Pinaka is a multi-barrel rocket launcher. So as you can see, it can launch multiple rockets simultaneously. Multi-barrel rocket launcher. It can launch multiple rockets simultaneously. So initially when we discussed the difference between a missile and a rocket, I told you that missiles are unguided weaponry. But in case of Pinaka rocket launcher, we have radar, navigation instrument, etc. So the rockets which are launched from Pinaka can be guided. Okay, they have better precision and accuracy. So Pinaka rocket launcher has the presence of radar guidance and navigation instruments. It has the presence of radar guidance and navigation instruments. So they will have better precision and accuracy. So they have better precision and accuracy. They have better precision and accuracy. So next we'll go to the surveillance systems. Surveillance systems. This is the last topic in defense. So surveillance system, we have to discuss radar, lidar, sonar and UAV. 4 things have to be discussed. So we'll start from UAV, unmanned aerial vehicles, UAV. UAV, unmanned aerial vehicles. So basically, when we tell about UAVs, we tell 2 names, right? UAV and is there, and then drone is also there. What is the difference between a UAV and a drone? Are they same? Are they different? No, is there any similarity between a UAV and a drone? What do you feel? UAV and a drone, are they same or are they different? Actually, there is some difference. See, for a UAV, unmanned aerial vehicle, it can take off and land in inclined manner. So inclined takeoff and inclined landing is possible. Drones you might have seen in your life, like wedding shoots, etc. We use drones. So drones, it is only possible for vertical takeoff and landing. Drones can have only vertical takeoff and landing. UAV can have inclined takeoff and landing. And what is the full form of drone? Again, you don't have to by heart and all. They will not ask full form, etc. But drone is dynamically remote operated navigation equipment. Drone. Dynamic remote operated navigation equipment. This is drone. And drone, only vertical takeoff and landing. Only vertical takeoff and landing. For UAVs, there is inclined takeoff and landing. inclined takeoff and landing. Okay, so UAVs can be basically classified into three. UAVs can be classified into three. First one is called general UAV. General UAV. General UAV. See, they are not used for combat. They are only used for ISR roles. They are only used for ISR roles. They are not used in battles. Intelligence, surveillance, and reconnaissance. Intelligence, surveillance, and reconnaissance. Reconnaissance is nothing but visual observation. This is reconnaissance. Reconnaissance is nothing but visual observation. So it is used only for ISR roles. General UAV is used only for ISR roles, intelligence, surveillance, and reconnaissance. And they are not used in combat battles. So first is general UAV. Second is unmanned combat aerial vehicle. Unmanned combat aerial vehicle, or UCAV. Unmanned combat aerial vehicle, UCAV. Unmanned combat aerial vehicles, or UCAV. They are capable of attacking but with non-missiles. They are capable of attacking but with non-missiles. They cannot use missiles, but they can attack. They are used for combat but with non-missiles. Unmanned combat aerial vehicle, capable of attacking with non-missiles. Then there is unmanned striking aerial vehicle. Unmanned striking aerial vehicle, USAV, capable of attack with missiles. Capable of attack with missiles. Capable of attack with missiles. So these are the different classifications of UAV. Now we will go to the different types of UAV we are having. First one is called Rustam. Rustam. Different different names of different UAVs India is having. First one is Rustam. Rustam is a light canard aircraft. Rustam is a light canard aircraft. Light canard aircraft. Light because it is made of carbon fibers. Light because it is made of carbon fibers. Light because it is made of carbon fibers. And canard is an aircraft with more than one pair of wings. Canard is an aircraft with more than one pair of wings. With more than one pair of wings. So it is a light canard aircraft. Light meaning it is made of carbon fibers. It is light in weight. And then canard is, it has more than one pair of wings. Light canard aircraft. Now there are three versions of Rustam which is developed by DRDO. First one is called Rustam 1. There are three versions of Rustam. First is Rustam 1. Rustam 1 is a general UAV. General UAV. Now we discuss the classifications. General UAV is used only for ISR roles. First one is a general UAV used only for ISR roles. So attacking is not possible using Rustam 1. It is not a combat UAV. Attacking is not possible. It can operate continuously for 16 to 18 hours. It can operate continuously for 16 to 18 hours. Rustam 1. It can operate continuously for 16 to 18 hours. Then we have Rustam H. Rustam H. This is also a general UAV. Rustam H is a general UAV. It can fly continuously for 22 to 24 hours. It can fly continuously for 22 to 24 hours. And it is a male UAV. It is a male UAV. Male has nothing to do with gender. Male meaning medium altitude, long endurance. Male is medium altitude, long endurance. Medium altitude, long endurance. So medium altitude means it can fly up to 30,000 feet. Medium altitude means it can fly up to 30,000 feet. And long endurance is something which can fly beyond 24 hours. Medium altitude as it can fly up to 30,000 feet. And long endurance as it can fly continuously for 24 hours or more. Long endurance as it can fly continuously for 24 hours or more. It can fly continuously for 24 hours or more. So this is medium altitude, long endurance. So this is a male UAV. And the next version is called Rustam 2. Third version is called Rustam 2. Rustam 2 is a UCAV. It is a combat aerial vehicle. It's a combat aerial vehicle and it is also a male UAV. Medium altitude, long endurance. It is also a male UAV which can operate continuously for 24 to 26 hours. It can operate continuously for 24 to 26 hours. Rustam 2. And there is a latest version which is getting developed by DRDO called Rustam C. There is a fourth version which is getting developed called Rustam C. It is still in development, so update yourself. What is happening with Rustam C? A latest version called Rustam C is under development. Rustam C. So this is Rustam 2. Okay, this is the Rustam. Next is Tapas. Next UAV is Tapas. Tapas is also a general UAV. General UAV. That is, it is used for ISR roles. General UAV. It is a male UAV, MALE, medium altitude, long endurance. It is a male UAV. It can fly continuously for 24 to 26 hours. It can fly continuously for 24 to 26 hours. It can fly continuously for 24 to 26 hours. So, this has no connection with the Rustam family. Generally, at some places, they give that Rustam 2 is called Tapas, which is wrong. Rustam 2 is a combat aerial vehicle. Tapas is generally it is a general UAV. So, Tapas is not a combat vehicle. It is used for surveillance. So, Rustam 2 is not Tapas. So, Tapas has no connection with the Rustam family. It is altogether a different UAV, Tapas. Next UAV is called Lakshya. Next UAV is called Lakshya. Lakshya is a pilotless target aircraft. Lakshya is a UCAV. Lakshya is a UCAV. It's an unmanned combat aerial vehicle, and it is a pilotless target aircraft, or PTA. Pilotless target aircraft. See, all the first Rustam, Rustam, Tapas, all were pilotless. So why this is called pilotless target aircraft? Is basically because Lakshya is a zero length launcher. Lakshya is a zero length launcher. Zero length launcher, which means the UAV will not have any wheels. UAV will not have any wheels, and it will not have any contact with the ground. UAV will not have any wheels or contact with the ground. It will not have any wheels or contact with the ground. It is launched from a mounter stand. It is launched from a mounter stand. You can see in the picture, there is a mounter stand. It does not have wheels. It is launched from a mounter stand. Launched from a mounter stand. And it has an inbuilt pair of wings. It has an inbuilt pair of wings. It has an inbuilt pair of wings for safe landing. For safe landing. So for landing, it uses its wings. For launching, we have a mounter stand. So it does not have wheels, or it does not come in contact with the ground. So this is Lakshya. It is a pilotless target aircraft. It has zero launch. It is zero length launcher. Okay, Lakshya is a zero length launcher. Now there is Abhyas, which is a modified version of Lakshya. Abhyas is a modified version of Lakshya. Modified version of Lakshya. It has two external fuel tanks. It has two external fuel tanks. It has two external fuel tanks, and one tank will be in operation at a time. And one tank will be in operation at a time. And when the fuel tanks get empty, when the tank gets empty, it will be detached. It will be detached so that the weight reduces. It will be detached so that the weight reduces. So when the weight reduces, obviously it will improve the speed and range. As the weight reduces, it will improve the speed and range. As the weight reduces, it will improve the speed and range. So what happens in the case of Abhyas, we have two fuel tanks. One fuel tanks get empty, it will be detached from the UAV, and only one fuel launcher will be used. So it will improve the speed and range, because we have two fuel tanks. It can fly for more length, more time. So this is Abhyas. So the basic advantage of a zero length launcher is that it can be launched from any platforms. It can be launched from aircrafts, helicopters, etc. The basic advantage of a zero length launcher is launching can be done from any platform. Launching can be done from any platform like aircraft, helicopter, etc. Launching can be done from any platform like this is Abhyas. As you can see, it is launched from a mounted stand. No connection with the wheel. So it uses the wings to come back. And both are UCAVs. Lakshya and Abhyas are combat aerial vehicles. We can drop weapons. Okay. So next is Netra. Next UAV is Netra. See, Netra, as you can see, is a small UAV and it is capable of vertical takeoff and landing. Netra is capable of vertical takeoff and landing. Capable of vertical takeoff and landing, and it is called a quadcopter. It is called a quadcopter. Quadcopter. Why quadcopter? It has 4 pair of wings or 4 span of wings. That is why it is called a quadcopter. It has 4 span of wings. That is why it is called quadcopter. And infrared cameras, thermal images are present. Infrared cameras and thermal images are present, which is used for night vision. Infrared cameras, thermal images, etc. are present, which is used for night vision. See, the unique feature of Netra is something called fail safety feature. Unique feature of Netra is its fail safety feature. Fail safety feature. Fail safety feature. What is this fail safety feature? See, as long as it takes off, it will record the latitude and longitude of the takeoff region. So even if the communication is lost with the operator, it can smoothly come back to its takeoff region. This is the feature called fail safety feature. Now, why this is important is Netra is used in disaster management, rescue operations, crowd management, etc. ISR roles it is being used in disaster management, crowd management, etc. So there is a possibility that the connection with the operator might get lost in a disaster environment. So even if the communication is lost, it will automatically come back to the place of launch because of this fail safety feature. So Netra has a fail safety feature. Netra has a fail safety feature where it is capable to record. Where it is capable to record the latitude and longitude of the takeoff region. Where it is capable to record the latitude and longitude of the takeoff region. So even if the communication signal gets interrupted, it will return back safely. Even if the communication signal gets interrupted, it will return back safely to the takeoff region. It will return back safely to the takeoff region. It will return back safely to the takeoff region. Hence, it is used for search and rescue operations. It is used for search and rescue operations. In disaster relief work. It is used for search and rescue operation in disaster relief work. It is used for crowd management. It is used for search and rescue operation in disaster relief. It is used for crowd management, etc. Search and rescue operation, crowd management. So it is used by both NDRF, National Disaster Response Force, and BSF, Border Security Force. It is used by NDRF and BSF, National Disaster Response Force, and BSF. Used by NDRF and BSF. So this is Netra. Next UAV is called Nishant. Nishant. So Nishant is developed under Project Falcon. So DRDO had a project called Project Falcon, under which they developed Nishant. So Nishant is a zero length launcher. It is a zero length launcher. It is a zero length launcher and it has certain unique stealth features. This is the importance of Nishant. Nishant has certain unique stealth features. What are the stealth features? First stealth feature is called broad spectrum technique. First stealth feature is called broad spectrum technique. So after finishing UAV, I will discuss all the stealth features together. Okay, this is a mains question, stealth feature. So there I will not be explaining this broad spectrum again because we already discussed it. So broad spectrum technique. First is called broad spectrum technique, where the UAV switches its operation. Between different ranges of the spectrum. UAV switches its operation between different regions of the spectrum. So it keeps changing the operating region of the spectrum, say infrared, ultraviolet, visible light. So it keeps changing the different regions of the spectrum. So as it keeps changing the spectrum, the operating regions of the spectrum, it is not possible to jam it. Okay, and hence it is free from electronic jamming. It keeps switching the operating region of the spectrum. And is free from electronic jamming. This is the first stealth feature, broad spectrum technique. And the entire UAV has, second is entire UAV has fiber reinforced glass. The entire UAV has fiber reinforced glass. The entire UAV has fiber reinforced glass, which is capable to absorb radio waves. So both these are the stealth features of Nishant. Broad spectrum technique and fiber reinforced glass. So DRDO had actually developed 4 Nishants, but all of them met with an accident, and currently no Nishant is under operation. So they have launched the Project Falcon again, and they have developed a modified version of Nishant called Punchy. DRDO has developed a modified version of Nishant called Punchy under Project Falcon. DRDO has developed a modified version of Nishant called Punchy under Project Falcon. Punchy. So Punchy also has this stealth features, broad spectrum, fiber reinforced glass, everything is there. Punchy also has stealth features like broad spectrum technique, fiber reinforced glass. Punchy also has stealth features like broad spectrum technique, fiber reinforced glass, etc. But Punchy is not a zero length launcher. Punchy is not a zero length launcher. Punchy has wheels. So Punchy is not a zero length launcher. Anchi is not a zero length launcher. So this is Nishant. So Nishant has certain features, fiber reinforced glass, then broad spectrum technique, etc. Then the last one is, last UAV is Aura. AURA, Aura. Aura is a USAV. USAV. Unmanned striking aerial vehicle. Aura is a USAV, unmanned striking aerial vehicle. Means it can launch missiles. USAV. And if we look into the shape of this UAV, can you identify any stealth feature? We have already discussed the stealth feature before also. So if you look into the shape of this UAV, it is triangle in shape, right? It is triangle in shape with sharp edges. So this feature of stealth is called delta wing configuration. So Aura has a stealth feature called delta wing configuration. Delta wing configuration, which is the triangle body appearance. Delta wing configuration, which is the triangle body appearance, which will scatter the radio frequencies, from enemy's radar, which will scatter the radio frequencies from enemy's radar. So there is a parallel project of Aura called Khatak. There is a parallel project of Aura called Khatak, which is a modified version of Aura. Khatak is a modified version of Aura. But Khatak uses Kaveri engine. Which is indigenous. It uses Kaveri engine, which is indigenous. We have discussed Kaveri engine before also. Do you remember where? Kaveri engine. Khatak uses Kaveri engine, which is indigenous. We had discussed Kaveri engine before also. Where did we discuss that? In Tejas. So Tejas uses Kaveri engine, which is indigenous. So Khatak also uses indigenous Kaveri engine. It is similar to Aura. Khatak also has delta wing configuration. No, Khatak is less a modified version of Aura. Delta wing configuration is there. It is an USAV. All these features are there. Delta wing configuration is there. This is also an USAV. Okay. But it uses Kaveri engine, which is indigenous. Now there are some micro UAVs which we have. Micro UAVs, just remember the name. Micro UAVs, black kite, golden hawk, black kite, BLACK, golden hawk, GOLDEN, golden hawk. Then there is slybird, SLYBARD, slybird, and pushpak, PUSHPAK, pushpak. Slybird and pushpak. Out of which slybird is imported from Israel. All the other are indigenous. Slybird is imported from Israel. All the other UAVs, micro UAVs are indigenous. All the other micro UAVs are indigenous. Now we will discuss a main topic called stealth technology features. Out of which few of them we have already discussed stealth technology. So stealth technology features, they are low observable technology. And it makes patrolling vehicles undetectable. to the vision of radar, sonar, etc. It makes patrolling vehicles undetectable to the vision of radar, sonar, etc. The first feature is called delta wing configuration. First stealth feature is delta wing configuration, which is a triangle body appearance. Delta wing configuration, triangle body appearance, used in manned and unmanned aircraft. Used in manned and unmanned aircraft. So we discussed about delta wing configuration in UAVs, no Aura, Khattakat delta wing configuration. Third generation aircraft, I told there is it has delta wing configuration, triangle shape appearance. So this is all part of it is a stealth feature in manned and unmanned aircraft. Delta wing configuration. Second is broad spectrum technique. Broad spectrum technique. So we discussed broad spectrum technique in just now in when we discussed UAV in Project Falcon. So Nishant had broad spectrum technique where it switches the ranges of spectrum. So it is used in broad spectrum techniques. It is used in UAVs, UAV 4 and 4.5 generation MAV. 4 and 4.5 generation MAV. If you remember, fourth generation aircraft when we discussed, even 4.5 generation when we discussed, I told you they have advanced stealth features. So this is a stealth feature they are having. Broad spectrum technique is used in UAV, 4th and 4.5 generation MAV and military tanks. And military tanks. 4 and 4.5 generation MAV and military tanks. Third is fiber reinforced glass. Fiber reinforced glass. Capable of absorbing radio waves. Capable of absorbing radio waves. Capable of absorbing radio waves. And we discussed in Project Falcon, it also uses this fiber reinforced glass. Project Falcon uses fiber reinforced glass. So again, used in UAV, MAV, military tanks, etc. Used in UAV, MAV, military tanks. Next is electrochromium painting. Electrochromium painting. So there are two uses of using electrochromium painting. First one, it absorbs the radio waves. Electrochromium painting, it absorbs the radio waves. It absorbs the radio waves and provides camouflage. It absorbs the radio waves and provides camouflage. See what is camouflage? You might have studied in schools regarding chameleon. The foreground color and the background color will be the same. Similarly, by providing this electrochromium painting, first one it absorbs the radio waves, second it provides camouflage. The foreground and the background color will be same. So it absorbs radio waves and provides camouflage. Next is plasmic cloud encirclement. Plasmic cloud encirclement. Plasmic cloud encirclement. So this is basically used for aircraft. See, aircraft will be surrounded by plasmic cloud. Aircraft will be encircled by plasmic cloud. Plasmic cloud. Plasma is the fourth state of matter which is ionized gases. Plasma is the fourth state of matter, ionized gases, which is capable of absorbing radio waves. Capable of absorbing radio waves. So you provide, a plasmic cloud around this aircraft. So this plasmic cloud will absorb radio waves. This is the plasmic cloud encirclement. Plasmic cloud encirclement. Next is adaptive water curtain technology. Adaptive water curtain technology. It is used in floating ships. It is used in floating ships, which continuously discharge water in its peripheral side. Which continuously discharge water in its peripheral side. So you might have seen naval ship discharging water from its peripheral side. So this is the water curtain technology. It is used in floating ships, which continuously discharge water from its peripheral side, and this water absorbs radio waves. Water absorbs radio waves. Water absorbs radio waves. So this is adaptive water curtain technology. Then AIP technology. AIP technology, which we have studied in submarines, right? In the third generation submarines, I told you, AIP is air independent propulsion. Air independent propulsion. So second generation submarines used diesel engines, so they had to come to the surface to get oxygen. In third generation submarines, there was a inbuilt chamber of hydrogen peroxide and nitric acid. So due to its reaction, oxygen will be provided. So it need not come to the surface. We had discussed this in submarines, third generation submarines. So air independent propulsion, which is used in diesel powered submarines. Diesel powered submarines. And then we have anti-torpedo defense system. Anti-torpedo defense system, which is also called confusing sonar. Anti-torpedo defense system, which is also called confusing sonar. So this is a protection against a torpedo. When a torpedo is coming to attack us, we can use this anti-torpedo defense system, confusing sonar, which confuses the incoming enemy's torpedo. Which confuses the incoming enemy's torpedo. Which confuses the incoming enemy's torpedo. So we have an anti-torpedo defense sonar called Marich. We have an anti-torpedo sonar called Marich. So you would have heard about the name of Marich in Ramayana. So Marich is a shapeshifter. So just before Sita was abducted, I think he shifted the shape to that of a deer and came and did some role. So similarly, this is confusing the enemy's torpedo. That is why it is. I think it is called Marich. So suppose the enemy's torpedo is coming to attack us. Torpedo is an underwater missile. So enemy's torpedo is coming to attack us. So it will be emitting sound signals, right? It will be having its own sonar. So it will be emitting sound signals and it will detect the location of the ship. The sonar will detect the location of the ship and then it will be coming to attack it. Now, what will happen is as it reaches near less than 50 nautical mile, our ship has its own sonar. Our ship has its own sonar. Now, when this torpedo reaches less than 50 nautical mile, the ship will launch something called cantos, which are ultrasonic sound emitters into the water. Okay, ship will launch something called ultrasonic sound emitters called cantos into the water. 13 cantos will be launched simultaneously. So around the ship, encircling the ship, there are 13 cantos. So this sonar of the torpedo will get confused because these 13 cantos operate randomly. One will operate at a time, which is an ultrasonic sound emitter. So cantos will produce sound and at the same time sound will be reflected from the ship also. So the sonar of the torpedo will get confused and it will not be able to precisely understand the location of the ship. So what it will do, it will encircle the ship without being able to understand the exact location of the ship. Its propellant will get exhausted, and it will automatically go to the bottom of the sea floor and will permanently rest there. So it will not be able to attack because we are confusing the torpedo. So this system is called anti-torpedo defense system or confusing sonar. Okay, so this is another stealth which we are using to which to make our ships and submarines invisible. So you can write, the torpedo will have its own sonar. The torpedo will have its own sonar. The torpedo will have its own sonar, which emits ultrasonic sound, and strikes the ship, which emits ultrasonic sounds that strikes the ship, and sonar collects the reflected signals, by knowing the time taken for transmitting and receiving the sound signals, sonar will be able to detect the distance of the ship. Sonar will be able to detect the distance of the ship. Next paragraph, you write, next paragraph. Up to 50 nautical miles, there will be no disturbance for the torpedo. Up to 50 nautical miles, there will be no disturbance for the torpedo. After 50 nautical miles, Marich will deploy cantos. After 50 nautical miles, Marich will deploy cantos, C-A-N-T-O-S, cantos, 50. After 50 nautical miles, 50 nautical miles, Marich will deploy cantos, C-A-N-T-O-S, cantos, which are ultrasonic sound emitters. So the cantos are metal boxes. In brackets, if you want, you can write, they are metal boxes which emits ultrasonic sound. They launch cantos which are ultrasonic sound emitters. 13 cantos will be launched. Which will be random in operation. 13 cantos will be launched, which will be random in operation. That is, one cantos will be operating at a time. Next paragraph, you write, next paragraph. Sound waves will be reflected from the ship. And the cantos. Sound waves will be reflected from the ship and the cantos. Torpedo will get confused. Torpedo will get confused and circulate the area near the ship. Torpedo will get confused and circulate the area near the ship and will not be able to strike. And will not be able to strike. The torpedo will lose its propellant. The torpedo will lose its propellant. Goes to the bottom surface of the seafloor. Go to the bottom surface of the seafloor and will remain inactive. And will remain inactive. Will remain inactive. This is a non-destructive methodology to protect the ship. This is a non-destructive methodology to protect the ship. The last of stealth is called intercepting sonar. So the last stealth feature is called intercepting sonar. Intercepting sonar. So this sonar will intercept the incomings. This sonar will intercept the incoming enemy's sonar signal. It will intercept the incoming enemy's sonar signal. It will intercept the incoming enemy sonar signal and alter its frequency. And alter its frequency. It will intercept the incoming enemy's signal and alter its frequency. So once the frequency is altered, the sonar will not get back any signal. The sonar will not get back any signal. So this is intercepting sonar. We will alter the frequency of incoming waves, incoming sound waves from the sonar. So this is used for floating ships and submarines. Used for floating ships and submarines. Used for floating ships and submarines. And we have two sonars called Panchendriya and Ushas, which are intercepting sonars. India has Panchendriya and Ushas, which are intercepting sonars. Panchendriya and Ushas, which are intercepting sonars. So these are the different stealth technology features. So I'll give you a break. After the break, we'll start the discussions from radar. So now we have radar, lidar, and sonar, which is there in the what we say surveillance. So we'll start with radar after the break. Pinaka, last point is that Pinaka uses radar and navigation systems. Pinaka uses radar and navigation systems so that it strikes the target with precision and accuracy. It strikes the target with precision and accuracy. Panchendriya and Ushas. We'll discuss sonars once again. Panchendriya and Ushas are examples of intercepting sonars. Panchendriya and Ushas are examples of intercepting sonars. You can take a 5 minutes break. So next topic is radar. Next topic is radar. So the question you can expect from radar is basically the names of radar. I don't think there is nothing beyond that which you might get. In the entire surveillance system, the names are more important. And if they want to complicate it, they can ask some features. No, we discussed different UAVs. So some features of Nishant or Aura, they can ask. This is a possible question. And then the stealth technology in general should be prepared from a mains perspective. So before going to the names, I'll just tell you what is a radar. Then we can discuss the names. So radar is radio detection and ranging. Radar is radio detection and ranging. Radio detection and ranging. It is a detection system that uses radio waves. It is a detection system that uses radio waves to determine the range, angle, and velocity of objects. To determine the range, angle is also called azimuth, and velocity. To determine the range, angle is also called azimuth, and velocity of objects. Range, angle, and velocity of objects. It can be used to detect aircraft, ships. It can be used to detect aircraft, ships, spacecraft, missiles, etc. Aircraft, ship, spacecraft, missile, etc. Aircraft, ship, spacecraft, missile, etc. Now, what are the different components of radar? First, we have a transmitter. There is a transmitter. So what is the role of a transmitter? It transmits, it produces the electromagnetic waves. Transmitter produces the electromagnetic waves. Transmitter produces the electromagnetic waves. So once the waves are produced, it should be transmitted. So there is an antenna. So generally there is one antenna for transmission and receiving. So there is one transmitting and receiving antenna. Transmitting and receiving antenna. Transmitting and receiving antenna. And then third, there is a receiver and processor. There is a receiver and processor to determine the properties of objects. There is a receiver and processor. So first there is a transmitter which produces these waves. Then there is an antenna which will transmit this waves. It will receive the waves. And then there is a processor, receiver and processor, to determine the properties of the objects. To determine the properties of the objects. To determine properties of objects. Now the classification of radars. Classification of radars. First is based on radio frequency source. Based on radio frequency source. There is active radar and passive radar. active radar and passive radar. Active radar and passive radar. So in the case of an active radar, the transmitter and receiver are located at the same place. The transmitter and receiver are located at the same place. And in the passive radar, transmitter and receiver are located at different places, different locations. Transmitter and receiver. So if the radio waves are produced from one place, received back at the same place, it is called active radar. If the radio waves are getting produced from some other regions and we are receiving it only, then it is called passive radar. Okay, production, the radio waves are coming from some other regions. We are only receiving the radio waves and then calculating the distance, the velocity, etc. It is called passive radar. So depending upon the radio frequency source, we have active radar and passive radar. Then depending upon the radio frequency signal, there is continuous and pulsating signals. There is continuous and pulsating. So continuous means the radio frequency signal will be continuous. Pulsating, it will be as pulses. Depending upon radio frequency signal, continuous and pulsating. Depending upon radio frequency signals as continuous or pulsating. Then depending upon the range, short range, medium range and long range. Short range, medium range and long range. Short range, medium range and long range. So if the range is less than 150 kilometers, it is short range. 150 to 350 kilometers, it is medium range. And greater than 350 kilometers, it is long range. Greater than 350 kilometers, it is long range. Short range, medium range and long range. Then dimensions, based on dimensions. There are 2-dimensional radars, there are 3-dimensional radar and 4-dimensional radar. 2-dimensional, 3-dimensional and 4-dimensional radar. So 2-dimensional radar will measure range and azimuth. Range and azimuth. Azimuth is basically the angle, angular distance. 2-dimensional radar will measure range and azimuth. 3-dimensional radar will measure range, azimuth and time. Range, azimuth and time. And 4-dimensional radar will measure range, azimuth, time and velocity. Range, azimuth, time and velocity. This is a 4-dimensional radar. It will measure range, azimuth, time and velocity. So this is based on the dimensions. And then last classification is based on area of operation. Area of operation. First is called surface based radars. Surface based radars. Operates on land as well as ships. Surface based radars operate on land as well as ships. Surface based radars operate on land as well as ships. Second is airborne radars. Airborne radars Permanently fixed at the top of an aircraft. Permanently fixed at the top of an aircraft. Permanently fixed at the top of an aircraft. And then there is portable airborne radar. There is portable airborne radar. Portable airborne radar, which is not fixed, not permanently fixed, like hot air balloons. Radars which are used in hot air balloons is an example of portable airborne radar. So surface based, used in land, ships, etc. Airborne radars are permanently fixed to aircraft. We'll see the names of different radars, then you'll understand. Then there is portable airborne radar. It is not permanently fixed. It keeps on, it can be changed from one aircraft to another, like hot air balloons. Right. Now we will see the names of different radars. First is swordfish radar. Swordfish radar. So we have already discussed about swordfish radar when we discussed our anti-ballistic missile system, anti-satellite missile system, etc. So first is swordfish radar. It is a long range, three-dimensional. This is a long range, three-dimensional active radar. It's a long range, three-dimensional active radar, which is indigenous. And it is the longest operating radar in India. Longest operating radar in India. Longest operating radar, range is 650 kilometers. Longest operating radar in India, range is 650 kilometers. It is a fire control radar. It is a fire control radar. See, fire control radar means it can launch missiles. Fire control radar means it can launch missiles. So we discussed it is capable to launch our anti-ballistic missiles, anti-satellite missiles. All these cases it was used. So it is capable of launching missiles. Example, our anti-ballistic missiles. It is capable of launching missiles. So it is called a fire control radar. Fire control radar. Next is Indra. Indra is a short range two-dimensional radar. Short range two-dimensional radar. It has target while scanning capacity. It has target while scanning capacity. That is, it is capable to destroy enemy's object at the time of scanning. Capable to destroy enemy's object at the time of scanning. Capable to destroy enemy's object at the time of scanning. Indra. It has a target while scanning feature. Next is Rajendra. Rajendra. Medium range, three-dimensional radar. Medium range, three-dimensional radar. It is a fire control radar. It is a fire control radar. What is a fire control radar? It is capable of launching missiles. So it is a fire control radar. Fire control radar. It is used to launch. Akash and Trishul. Used to launch Akash and Trishul. And it is a silent radar. It is a silent radar. Silent radar means it is a weapon locating radar in the battlefield. It is a weapon locating radar in the battlefield. This is the meaning of a silent radar. It is a weapon locating radar in the battlefield. Rajendra. Then we have Swati. Swati, which is a short-range two-dimensional radar. Swati is a short-range two-dimensional radar. It is used by the Army and Navy. Used by Army and Navy. It is also a silent theater radar. It is also a silent theater radar. Swati is a silent theater radar, which means it is used for locating weapons. Here it is used to find mines. Okay, so this is used to detect land mines in the battlefield. Swati is used to detect land mines in the battlefield. Used to detect land mines in the battlefield. Used to detect landmines in the battlefield. Next is Rohini. Rohini. Rohini is a medium range three-dimensional radar. Medium range three-dimensional radar used by Air Force. Medium range three-dimensional radar used by Air Force. Medium range three-dimensional radar used by Air Force. It is a central acquisition radar. It is a central acquisition radar or CAR. Central acquisition radar, CAR. Central acquisition radar, CAR, means the radar is capable to surveil. The radar is capable to surveil 360 degree. The radar is capable to surveil 360 degree. This is called a central acquisition radar, CAR. Radar is capable to surveil 360 degree. Central acquisition radar. Central acquisition radar. It is capable of guiding multiple targets. It is capable of guiding multiple targets. Capable of guiding multiple targets. It can guide 200 Akash missiles simultaneously. It can guide 200 Akash missiles simultaneously. It can guide 200 Akash missiles simultaneously. Can guide 200 Akash missiles simultaneously, and it also has TWS capacity. It also has TWS capacity, target while scanning. It also has TWS, target while scanning capacity. It also has TWS, target while scanning capacity. Then there is Revati. Revati, which is a cloned naval version of Rohini. Revati is the cloned naval version of Rohini. Same features. Whatever Rohini has is same as say Revati also has all the same features, but it is used by Navy. Okay, so the cloned feature is a medium range three-dimensional radar. It also is a central acquisition radar. It is capable of targeting guiding multiple targets. It is TWS capacity is there. So all features are same. So cloned naval version of Rohini is called Revati. Cloned naval version of Rohini is called Revati. Then there is Bharani. Bharani. Long range two-dimensional radar. Long range two-dimensional radar. Bharani is a long range two-dimensional radar. Range is approximately 450 kilometers. Long range two-dimensional radar. It is used for UAV surveillance. It is used for UAV surveillance. We use this Bharani to detect UAVs. So this is used for UAV surveillance. It's used for UAV surveillance and detecting cruise missiles. For detecting cruise missiles, because the shape of cruise missiles is zigzag, it is not very easy to detect where exactly is a cruise missile. So this Bharani can detect cruise missiles. It is used for UAV surveillance and detecting cruise missiles. Bharani is used by Indian Army. Used by Indian Army. Then there is Arudra. There is Arudra. Medium range 4-dimensional radar. Medium range 4-dimensional radar. And it is used for UAV and MAV surveillance. UAV and MAV surveillance. Arudra is a medium range 4-dimensional radar used for UAV and MAV surveillance. So basically it is used in airports. This is used in airports, Arudra. UAV and MAV surveillance. Then we have an Israeli radar called Aerostat. There is an Israeli radar called Aerostat. So as you can see, this is fixed to a portable hot air balloon. So this is a portable airborne radar. So next is Aerostat. Aerostat. It is a medium range. It is a medium range, 3-dimensional, medium range, 3-dimensional, portable airborne radar. Medium range, 3-dimensional, portable airborne radar. Medium range, 3-dimensional, portable airborne radar. And it is an Israeli radar. It's an Israeli radar. So there is another Israeli radar called AWACS. There is another Israeli radar called AWACS. That is Airborne Warning Air Control System. Airborne Warning Air Control System. Airborne Warning Air Control System. This AWACS has a range of 400 kilometers. AWACS has a range of 400 kilometers and can cover 360 degrees. And can cover 360 degrees. It has a range of 400 kilometers and can cover 360 degrees. Now, Aerostat can be integrated with AWACS. Aerostat can be integrated with AWACS. Aerostat can be integrated with AWACS. And the range can be increased to 750 kilometers. Aerostat can be integrated with AWACS and the range can be increased to 750 kilometers. 350 already Aerostat has. So it can be integrated with AWACS. So 350 plus 400, total of 750 kilometer will be the range. So it can be integrated with AWACS and the range will increase to 750 kilometers. So AWACS is an Israeli system. We have developed our own airborne system called Netra. Netra. Netra is an indigenous airborne system. Indigenous airborne system. It is not portable. As you can see, it is fixed to the top of an aircraft. Right? So it is an indigenous airborne system. Indigenous airborne system or airborne radar. It is called AEWCS. AEWCS. Airborne Early Warning and Control System. Airborne Early Warning and Control System. It is an indigenous airborne radar, airborne early warning and control system, AEWCS, range of 200 kilometer and 270 degree. Range of 200 kilometers and 200 kilometer and 270 degree. And the last is Uttam, which is also an airborne radar. So that means it is fixed to an aircraft. We basically fix Uttam to Tejas. It gets operated with Tejas. Uttam gets operated with Tejas. It gets operated with Tejas. It can track 100 targets simultaneously. It can track 100 targets simultaneously. Can track 100 targets simultaneously. It can track 100 targets simultaneously. So this is about radar. We discussed the different names of radar. So possibly they can ask 2-3 radars and ask what it is. Or if they want to make the question a bit more complex, they can ask some features of these radars. This is what can be expected from a question prelims perspective. Next is LIDAR. So if radar was radio detection, LIDAR is light detection and ranging. Light detection and ranging. So LIDAR is, LIDAR consists of multiple equipments. LIDAR consists of a laser. LIDAR consists of laser, GPS. It consists of laser, GPS, altitude sensors. It consists of laser, GPS, altitude sensors, and other electronic equipments. See, radar cannot operate underwater. Okay. So LIDAR will overcome this problem. LIDAR can operate both underwater and above water. So radar cannot operate underwater. LIDAR can penetrate underwater. LIDAR can penetrate underwater and overcomes the limitations of radar. LIDAR can penetrate underwater and overcomes the limitation of radar. So there are two types of LIDAR: topographic LIDAR and bathymetric LIDAR. We have topographic LIDAR and bathymetric LIDAR. Topographic LIDAR and bathymetric LIDAR. Topographic LIDAR is used for land surveillance. And bathymetric LIDAR is used for underwater surveillance. Topographic LIDAR is used for land surveillance and bathymetric LIDAR is used for underwater surveillance. So India does not have any LIDARs. So you do not have to study. You are saved. No names of LIDAR has to be studied as of now. If at all we buy any LIDARs, we develop any LIDARs, names have to be studied. Next, the last topic is, in surveillance, the last topic is sonar. Sonar is sound, navigation and ranging. So we use ultrasonic sound and it is used only underwater. So sonar is used for underwater detection. Sound, navigation and ranging. Capable to operate only in water. And it uses ultrasonic sound for detection. uses ultrasonic sound for detection. Uses ultrasonic sound for detection. Again, classification. Sonars can be classified on the basis of the radio frequency sources. Sorry, on the basis of sound sources. On the basis of sound source, it can be classified into active sonar and passive sonar. First classification of sonar. First is based on the source. First is based on the source. Based on the source, it can be classified into, just right, based on the source, it can be classified into active sonar and passive sonar. Active and passive sonar. So active sonars have permanent fixation. Active sonars have permanent fixation. And both transmission and reception happens from the same location. Transmission and reception, it is permanently fixed. You know, wherever we are using it, ship, submarine, etc., wherever we are using it, it is permanently fixed, and transmission and reception happens from the same location. Transmission and reception happens from the same location. Passive sonar is not permanently fixed. Passive sonar is not permanently fixed. And only receiver is there. Only receiver, not permanently fixed, and only receiver. Not permanently fixed, and only receiver is there. Okay, this is the first classification. And next is the based on the location of the sonar, where it is fixed. So as I told, it can be fixed either on the side of a ship or at the bottom of the ship. So if it is fixed at the bottom, it is called hull mounted sonar. Hull mounted sonar. And if it is fixed on the side, it is called towed array sonar. Towed array sonar. So first is hull mounted sonar. Hull mounted sonar. Fixed at the bottom of the ship. Hull mounted sonar fixed at the bottom of the ship. And then there is towed array sonar, TOWED, towed array sonar. Towed array sonar fixed on the rear or front side of the ship. Fixed on the rear or front side of the ship. Fixed on the rear or front side of the ship. Third classification is based on range. Based on range. Sonars are classified into long range and short range. Sonars are classified into long range and short range. Long range and short range. So if it is capable of operating beyond 50 nautical miles, it is long range. If the sonar is capable of operating beyond 50 nautical miles, it is long range. If it operates less than 50 nautical miles, if it operates less than 50 nautical miles, it is short range. Long range and short range. Now the different sonars we are having. First one is called APSO. APSO, APSOH, APSO. APSO. It is an active hull mounted long range sonar. Active hull mounted long range sonar. Used for deep ocean water surveillance. Used for deep ocean water surveillance. Only in floating ships. only in floating ships. So it is an active sonar. It is a hull mounted sonar, and it is used for long range surveillance. It can surveil more than 50 nautical miles, and it is used in deep ocean water, okay, by floating ships. This is UPSO, and Hamvad is a modified version of UPSO. Hamvad is a modified version of UPSO, which can operate in shallow and deep ocean waters. Which can operate in shallow and deep ocean waters. Hamvad is a modified version of UPSO, which can operate in shallow and deep ocean waters. Next is Hamsa. Hamsa, it is kind of similar to UPSO only. Hamsa, it is an active hull mounted long range sonar used in deep ocean water, and Hamsa NG is a modified version of Hamsa. Yes, Hamsa can operate in deep ocean water, I told you. Hamsa NG is a modified version of Hamsa called Hamsa Next Generation. Hamsa NG is a modified version of Hamsa called Hamsa Next Generation. It is a short range sonar. Used in deep and shallow waters. Short range sonar used in deep and shallow waters. Next is Marich. We already discussed Marich. It is an anti-torpedo defense system. And it is used for short range surveillance. If you remember, I told when the torpedo is less than 50 nautical miles only, the Cantos are launched. So it is short range. It will cover only 50 nautical miles. This is used for short range surveillance. And it is operated from, currently it is operated from INS Chennai and Scorpion class submarines. Currently it is operated from INS Chennai and Scorpion class submarines. It is operated from INS Chennai and Scorpion class submarines. So only 3 countries have this anti-torpedo defense system: USA, Russia, and India. So only 3 countries have anti-torpedo defense system: USA, India, and Russia. Then we have Panchendriya. We have discussed this also. Panchendriya. It is the first indigenous sonar of India. Used for submarine operations. Panchendriya is first indigenous sonar used for submarine operations. And a modified version of Panchendriya is called Ushas. Panchendriya is the first indigenous sonar. It is used for submarine operations. Modified version of Panchendriya is called Ushas. Both are intercepting sonars. We discussed about in the stealth feature about intercepting sonar. So Panchendriya and Ushas are intercepting sonars. Mihir. It is a passive sonar. And gets operated from light helicopter called Dhruv. We have a light observable helicopter called Dhruv. So it gets operated from Dhruv. This Mihir gets operated from Dhruv. here gets operated from Dhruv, which is a helicopter, light helicopter, because it is made of carbon fibers. So it is a light helicopter, Dhruv, and it gets operated from Dhruv. And the last of the sonar is ACTAS. ACTAS. So this is a towed array sonar. Towed array sonar. ACTAS is a towed array sonar. Imported from Germany. Imported from Germany. Used for both floating ships and submarines. Used for both floating ships and submarines. Used for both floating ships and submarines. So this is about sonars. So there was one topic which I initially skipped. The organizational structure of Ministry of Defense. The organizational setup of Ministry of Defense. We'll discuss this also. Organizational setup of Ministry of Defense. Organizational setup of Ministry of Defense. See, the first 4 departments, Ministry of Defense have 5 departments. The first 4 departments have been there from, from the time the ministry was created. But the 5th department was created only last year. Department of Military Affairs. So the first 4 departments have been already there. We'll quickly discuss all these departments. So I'll give you a statement. Tell me if it is right or wrong. The Supreme Commander of Indian Defense System is the Prime Minister. True or false? The Supreme Commander of Indian Defense System is the Prime Minister. True or false? It is false. The Supreme Commander is President. Okay. So the Supreme Commander of Indian Defense System is the President of India. Supreme Commander of Indian Defense System is the President of India. But the Supreme Commander role is only nominal. The decisions are ultimately taken by Ministry of Defense. But the administrative control is with Ministry of Defense. Administrative control is with Ministry of Defense. Supreme Commander of Indian Defense System is the President of India. Administrative control is with the Ministry of Defense. Administrative control is with Ministry of Defense. So Ministry of Defense have 5 departments. Department of Defense, Department of Defense Production, Defense Research and Development, Ex-Servicemen Welfare and Military Affairs. So we'll discuss one by one. First is Department of Defense. First one is called Department of Defense. They deal with integrated defense staff. First function is they deals with integrated defense staff. They deal with integrated defense staff. They deal with integrated defense staff, which is responsible for coordination of different branches of armed forces. Which is responsible for coordination of different branches of armed forces. Which is responsible for coordination of different branches of armed forces, and was created in 2002. And was created in 2002. Created in 2002. See, at the time of Kargil war, there was a lot of discussions regarding the coordination between the 3 wings, Army, Navy, Air Force. Suppose a war comes, how to coordinate the activities of these 3 organs of armed forces. So that is why different committees were formed after the Kargil war, and these committees recommended the creation of something called CDS, Chief of Defense Staff. Okay, they recommended the creation of Chief of Defense Staff, which was only created in 2020. But in 2002 itself, we created something called Integrated Defense Staff, and it was under the Ministry of Department of Defense. And this was responsible for, coordinating the different activities of the different branches of the armed forces, Army, Navy, Air Force. And currently, Integrated Defense Staff, IDS, assists the CDS. Currently, this assists the CDS. Currently, they assist the CDS. They assist the CDS because now CDS is there. CDS is actually coordinating all these branches. So IDS assists CDS. This is the first responsibility. Second, it deals with all the parliamentary affairs, or it deals with all the parliamentary matters of defense. Deals with all the parliamentary matters like defense budget, defense policy, etc. It deals with all parliamentary matters like defense budget, defense policy, etc. Second duty is it deals with all the parliamentary matters like defense budget, defense policy. And the third function is it deals with the defense cooperation with foreign countries. It deals with defense cooperation with foreign countries. It deals with defense cooperation with foreign countries. It deals with the defense cooperation with foreign countries. So these are the responsibilities of Department of Defense. Next is Department of Defense Production. Department of Defense Production. So from the name itself, they deal with the production. So indigenization, they will deal with the indigenization of equipments. So if something has to be produced from India, Department of Defense Production takes care of it. They take care of indigenization of equipment. They deals with indigenization of equipment. And we have something called Ordnance Factory Board. Not ordinance, Ordnance Factory Board. And the defense PSUs. So Department of Defense Production, deals with the planning and control of both of this. The planning and control of ordnance factories. So ordnance factories where we actually manufacture our artillery, manufacture our military equipments. This is in the ordnance factory. So there is a service itself called Ordnance Factory Service. Once you clear the UPSC exam, so there are different services. Now I think there are 17 or 18 services. So IAS, IPS, all this after, if you do not get these top services, you will come to the other services. So one such service is Ordnance Factory Service. If you are selected into an Ordnance Factory Service, you will be the administrator of one such ordnance factory. So this ordnance factory is under the control of Department of Defense Production. Ordnance factory as well as defense PSUs like HAL, Masgaon Dock Limited. So HAL is our in Bangalore. They manufacture our aircraft, helicopters, etc. Hindustan Aeronautics Limited. And at Masgaon Dock Limited is our shipbuilding center. So all these defense PSUs, the planning and control is by Department of Defense Production. So they deal with the planning and control of Ordnance Factory Board, defense PSUs, etc. Ordnance Factory Board, defense PSUs, etc. Next is Department of Defense Research and Development. Department of Defense Research and Development. Defense Research and Development. They advises the government on. Scientific aspects of. They advises the government on scientific aspects of military equipment and logistics. Military equipment and logistics. Basically R&D. New research, new development, new technology, everything research and development is done by this department. Then there is Department of Ex-Servicemen Welfare. There is Department of Ex-Servicemen Welfare. Department of Ex-Servicemen Welfare. So basically resettlement, welfare, pension. It deals with the resettlement, welfare, pension of ex-servicemen. It deals with the resettlement, welfare, pension of ex-servicemen. So these 4 departments are headed by a secretary. Okay, so secretary, you might have studied in your governance classes. So this is an organizational hierarchy of a ministry. So the administrative head is secretary. We have additional secretary. We have joint secretary. We have deputy secretary. And we have under secretary. This is the organizational hierarchy of a ministry. So these are all administrative officers. So if you are entering as an IAS officer, you will be a deputy secretary. Okay, the level will be deputy secretary. After almost 10 years, 8 to 10 years, you will become joint secretary. Then 8 to 10 years, you will become additional secretary. After almost 32 years of service, you will become secretary. Okay, this is the topmost administrative post. And earlier, all the secretary posts of all ministries, departments were held by IAS officers. The secretary post. Now the current government is giving this post to other services also, like IPS, IRS, audit and account officers. All of them are becoming secretaries. Okay, so basically secretaries are civilian officers, administrators. Okay, so all the 4 departments which I told you, Department of Defense, Department of Defense Production, Department of Defense Research and Development, Department of Ex-Servicemen Welfare, all of them are headed by secretaries, administrators who are civilian officers. Now the government has created a 5th department called Department of Military Affairs, which is headed by a military officer. Now a 5th department is created, Department of Military Affairs, which is headed by a military officer called Chief of Defense Staff, CDS. Department of Military Affairs, headed by Chief of Defense Staff, CDS. Chief of Defense Staff, CDS. Department of Military Affairs. Department of Military Affairs deals with the operational synergy between 3 services. Operational synergy between 3 services. So again, all of them have to function together. When a war comes or when there is necessity, there should be operational synergy, coordination between these 3 services, Army, Navy, Air Force. So this is ensured by Department of Military Services. Now CDS again is a military officer, and what is his main function? He is like a leader. He provides effective leadership at the top of the 3 wings. CDS, Chief of Defense Staff. CDS, Chief of Defense Staff, provide effective leadership. Provide effective leadership at the top level. Provide effective leadership at the top level of 3 wings of armed forces. He provide effective leadership at the top level of 3 wings of armed forces and improve coordination among them. And improve coordination among them. And improve coordination among them. So he, the CDS can provide directives to the 3 chiefs, but he does not have any commanding authority over the forces. He cannot give commands to the forces. The commanding authority is with the chiefs only, but he can give directive to the 3 chiefs. So CDS have operational and strategic authority. He has operational and strategic authority. He has operational and strategic authority over the defense forces. Over the defense forces. But he is not its commander. But he is not its commander. So the commanding power is with the chief of the services only. He does not have the commanding power. And CDS is a single point military advisor. CDS is a single point military advisor to the defense minister. CDS is a single point military advisor to the defense minister. CDS is a single point military advisor to the defense minister. On matters involving all the three services. On matters involving all the three services. Is a single point military advisor to the defense minister on matters involving all the three services. So Bipin Rawat was actually General Bipin Rawat was appointed as the first CDS. He assumed office on 1st January 2020 and is given a 3-year tenure. Okay, so till the age of 65, 3 years is a tenure of CDS, and he will serve till 2022. So this is the officer of CDS. You might study more about CDS in internal security also, in defense, etc. CDS is a new position which is created. So with this, we are, the defense topic is over. Defense topic is over. So after the break, we will start with information communication technology, ICT. So we will be starting with information communication technology after the break. Any doubts? Any doubts? So in ICT, I'm not starting. I'll start it after the break only. What are the major topics we'll be discussing? We can classify it into prelim specific topics and main specific topics. So it does not mean that this prelim specific topics will not come in mains or mains topics will not come in prelims. It can come both ways, but more focus or more probability of questions will be there in prelims regarding these topics. So prelims test specific topics include modern computing terminologies, then we'll be discussing about malwares, then data transfer technologies like Bluetooth, Wi-Fi, all these things, data transfer technologies. Data transfer technology. Then we will be discussing about different generation of mobiles. We will discuss about different generation of mobiles. And last topic is digital payment systems. Digital payment systems. Digital payment systems. So these are the prelim specific topics we'll be discussing in ICT. Computing terminologies like supercomputers, quantum computers, cloud computing, all these things we'll discuss. Malwares, so virus, ransomware, all these things, Trojan. Then data transfer technologies, so Bluetooth, Wi-Fi, all that, Li-Fi, all those technologies. Then generation of mobile phones, starting from 0G to 5G. What changes came in all generations. And the last is digital payment systems. So this will be the topics from a prelims perspective. And from a mains perspective, all those things which is related to the 5th industrial revolution, big data, Internet of Things, artificial intelligence and robotics, then blockchain technology, cryptocurrency, and we will discuss about net neutrality also. Net neutrality. So these are the main specific topics we'll be discussing. Big data, Internet of Things, artificial intelligence and robotics, blockchain technology, and net neutrality. So I think we'll continue the session at 5 o'clock. Can join back at 5. Any questions? Okay. So good evening, welcome back. Am I audible? Okay, so I think before the break, somebody was asking about the sessions. So I think this is my fifth class, right? For fifth class. After this, there will be three more sessions. From my end, there will be three more sessions. Total 8 sessions will be there for from my part, science and technology. The other half will be taken by Sucharitan sir. Okay. So the first topic is in ICT is modern computing terminologies. Modern computing terminologies, and we'll start with supercomputing. So the first type of modern computing is supercomputing. Supercomputing. It is done with the help of supercomputers. It is done with the help of supercomputers. Supercomputers are world's fastest computers in the current scenario. They are world's fastest computers in the current scenario. See, in the current scenario, because we are developing quantum computers, so quantum computers is any day faster than supercomputers. But quantum computers have not become yet operational, even though some people have claimed that they have developed operational quantum computers, like Google have told, they have achieved quantum supremacy. But still, from an operational point of view, it is not, widely used as supercomputers. But supercomputers are getting used. So as of now, these are world's fastest computers. So why they are called fastest computers? They are called high performance computers. They are high performance computers. They are high performance computers. Now why they are high performance computers? Because they are able to execute high number of instructions per second. They execute high number of instructions per second. They execute high number of instructions per second. This high number of instructions per second is measured in something called flops rate. Okay, it is measured in flops rate, that is floating point operating system. It is measured in floating point operating system. So high number of instructions per second means we will tell high flops rate. High flops rate, that is floating point operating system. High flops rate. High flops rate. We generally tell supercomputers have high flops rate. That is floating point operating system. So the flops rate is greater than 2 billion instructions per second. So generally flops rate is 2 billion instructions per second. 2 billion instructions per second. For our normal laptops, computers, etc., this is approximately million instructions. Okay, it is million instructions. That is when supercomputers execute 2 billion instructions per second. For normal laptop and desktop, it is measured in MIPS, million instructions per second. For laptops, desktops, etc., it is measured in million instructions per second, MIPS. For supercomputers, it is billion instructions per second, not million, but billion instructions per second. And fastest supercomputers can execute quadrillion instructions per second. Fastest supercomputers can execute quadrillion instructions per second. Quadrillion instructions per second. That is million billion instructions per second. Million billion instructions per second. Quadrillion is million billion instructions per second. So that is 10 raised to 6 into 10 raised to 9 instructions per second, or 10 raised to 15 instructions per second. So 10 raised to 15 is called peta, right? So we measure it in petaflops. So the fastest supercomputers execute operations, it is capable of executing 10 raised to 15 operations per second, or we call it petaflops. So if I say a supercomputer speed is 1 petaflop, that means it is capable to execute 10 raised to 15 instructions per second. So that much fast it will be performing. So petaflops, 10 raised to 15 is called petaflops. Petaflops. Or if it is not as fast as petaflops, it can be either, it can be else teraflops. Teraflops is 10 raised to 12 instructions per second. Petaflops is 10 raised to 15 instructions per second. And teraflops is 10 raised to 12 instructions per second. Teraflops is 10 raised to 12 instructions per second. Now, supercomputers are task specific in nature. They are task specific in nature, or they are capable of doing one task at a time. They are capable of doing one task at a time. Suppose there is a supercomputer A which is capable of doing mathematical modeling, weather modeling, chemical analysis, etc. So suppose there is a supercomputer which can perform multiple operations. At one point of time, the supercomputer will be performing only one task, even though it is capable of performing multiple tasks, because the task which will be given to supercomputer is a highly complex task. We will not make it do multiple tasks. Rather, we will be focusing on one specific task. It can be either mathematical modeling, or it can be chemical analysis, or it can be weather forecasting, weather analysis. So all this can be performed at one time. We do one function. Generally in our ordinary laptops, etc., we can perform multiple tasks together. Maybe you will be typing something in Word at the same time. MP3 might be playing in the MP3 player. Google Chrome might be open. You might be searching something in Google Chrome. Telegram might be downloading something. So multiple tasks can be performed simultaneously. But this is not done in a supercomputer. Hence, it is task specific in nature. Task specific in nature. It is task specific in nature. They are capable of doing one task at a time. We service normal computers. We service normal computers where multitasking is possible. We service normal computers where multitasking is possible. And second, supercomputers. Another feature is supercomputers have inherent parallelism. They have inherent parallelism. They have inherent parallelism. That is connecting more than one supercomputer at a time. Connecting more than one supercomputer at a time. to perform a single specific task. To perform a single specific task. Connecting more than one supercomputer at a time to perform single specific tasks. I'll give you examples of inherent parallelism when we discuss names of supercomputers. So this is like more, you're connecting not just one supercomputer, multiple supercomputers are connected, but for doing the same task. This is called inherent parallelism. This is possible. You can connect more than one supercomputers to perform a single task. Okay, so this property is called inherent parallelism. Now we'll discuss So now we'll discuss, and the probable question also from this topic will be the names of supercomputers. Okay, will be the names of supercomputers. So we'll discuss the fastest supercomputers in the world. Do you know the name of the fastest supercomputer in the world? Which is the fastest supercomputer in the world, and to which country does it belong to? Fastest supercomputer in the world, and to which country does it belong to? Anybody has any idea? Yes. Not USA. Currently, the fastest supercomputer belongs to Japan, and the name is Fugaku. Currently, the fastest supercomputer, this has been, this became the fastest supercomputer only in June 2020. Okay. So till then, as you said, it belonged to USA. The fastest supercomputer was Summit, which belonged to USA. But currently, the fastest supercomputer is Fugaku, which belongs to Japan, or which belongs to Japan. Fastest supercomputers. First one is Fugaku, which belongs to Japan. The fastest supercomputer in the world, is Fugaku. Fugaku, Fugaku, which belongs to Japan. Fugaku is actually an alternative name to Mount Fuji. It's an alternative name to Mount Fuji. So again, when we discuss the different supercomputers, I think certain things you should remember is, first thing, it belongs to which country. Second, you can remember the speed of supercomputers. Third, for what all purpose it is being used. These are the three things you should remember. And fourth is, if it has some unique features, the supercomputer has some unique features that can be remembered. These are the only things. Most probably they will ask is like Fugaku, as recently heard in news, is a supercomputer, is a mission of NASA, this kind of, or is it is a Japanese virus. So whatever, sorry, it is a Chinese currency. This kind of options can be framed regarding a word like Fugaku can be given, and this options can be given. This is the easiest question you can expect. Or if they want to make it complex, they can ask Fugaku, which is a supercomputer. Consider the following statements. 2-3 statements will be given. It belongs to Japan. The speed is so and so terabytes, and it is used for this purposes. So multiple statements might be given, and you can be asked to pick the correct statement. This is the possible questions you can expect from this area, supercomputers. So Fugaku belongs to Japan, as I told, and the speed is 415.5 teraflops. 415.5 teraflops is the speed of Fugaku. 415.5 teraflops. This is the speed of Fugaku. Again, you don't have to remember it in the micro values, 415.5. Approximately you remember, that is enough. 415.5. So a Japanese supercomputer is gaining the first position after a gap of 9 years. Okay. So after a gap of, before this, for 2 years, USA had the first position. Before this, for 4-5 years, China had the first position. So almost for 9 years, Japan was not having this top supercomputer. Now Japan is again gained the first position. So this is developed by a private firm. You might have heard about this. This is developed by Fujitsu and Riken Research Institute. developed by Fujitsu and Riken Research Institute. Fujitsu and Riken Research Institute. And this is the first supercomputer based on ARM processor. First supercomputer based on ARM processor. ARM processor. ARM. ARM. ARM is Advanced Risk Machines. Advanced RISC Risk Machines. Advanced Risk Machines. RISC Advanced Risk Machines. So RISC is Reduced Instruction Set Computer. RISC RISC, Reduced Instruction Set Computer. Reduced Instruction Set Computer. RISC, the RISC computer. It is a part of the RISC family. Okay, it is the first supercomputer based on ARM processor, Advanced RISC Machine. So ARM processor is one of the family of CPUs. ARM processor is one of the family of CPUs based on RISC, RISC, based on RISC. Reduced Instruction Set Computer. Reduced Instruction Set Computer. So from the name itself, as you can see, they are given or they are made to perform smaller set of computer instructions. So when they are given smaller set of computer instructions, they will perform at a higher speed. So this is called the RISC processors. And this ARM processors are basically used in our smartphones, multimedia players, the wearables, watches, etc. We use ARM processors. This is the first time we are using an ARM processor in a supercomputer. So when we use this RISC processors, reduced instruction set computer processors, so they weed out the unwanted instructions. They will weed out or they'll strip out the unwanted instructions. Only required instructions are taken. So when only required instructions are executed, obviously the power required will be lesser. It will only require a fraction of power as compared to other processors. Plus, it will be smaller in size because of the reduced instruction set. No, the processor will be smaller in size. Hence, the entire system will be smaller in size. So they are called miniaturized systems. That is why basically these processors are used in our smartphones, wearables, etc. They'll strip out the unwanted instructions. They will execute only the needed instructions. So they can be smaller in size. So this is the first time an ARM processor is getting used in a supercomputer. So they are designed to perform RISC processors are designed to perform smaller set of computer instructions, so that they can operate at higher speed. They are designed to perform smaller set of computer instructions so that they can operate at higher speed. ARM processors are generally used in smartphones, wearables, multimedia players, etc. Smartphones, wearables, multimedia players, etc. Smartphones, wearables, multimedia players, etc. RISC processors, RISC RISC processors strips out RISC processors strips out unneeded instructions. It strips out unneeded instructions and hence require only a fraction of power, as compared to other processors. It strips out unneeded instructions and hence require only a fraction of powers as compared to other processors. And because of reduced instruction set, they are smaller in size. They are smaller in size and are called miniaturized systems. They are smaller in size and is miniaturized systems. They are smaller in size and is miniaturized systems. So what is it used for? They are used for both scientific and social purposes. Scientific and social purposes. Used for scientific and social purposes like they are used for weather simulations. They are used for weather simulations. Simulate natural disasters. Natural disasters simulation. Natural disaster simulation. Even in coronavirus research, it was used in coronavirus research. Coronavirus research. Then it is used in clean energy development. Clean energy development. Drug discovery, etc. Clean energy development, drug discovery, etc. So these are the different uses. See, most of them have multiple overlapping uses. Okay, if at all there is anything unique, just remember. So this was used in coronavirus research. It is used for not just scientific purpose, even for social purposes like clean energy development, drug discovery. It is used for social as well as scientific purposes. So this is the fastest supercomputer in the world currently, Fugaku. Okay. Now the second fastest supercomputer, there's nothing much to show here. It is all processors stacked. So it will take rooms to fill all these processors. Second fastest supercomputer in the world is Summit. Second fastest supercomputer in the world is Summit. Summit, which belongs to USA. SUMMIT, Summit, which belongs to USA and was developed by IBM. Summit, which belongs to USA, developed by IBM. So this was the fastest supercomputer in the world. For almost 2 years, Summit was the fastest supercomputer until replaced by Fugaku. Summit belongs to USA, developed by IBM. And the speed varies between 150 to 200 petaflops. The speed of Summit is, so initially it was 150, now they have increased the speed to 200 petaflops. So speed is 150 to 200 petaflops. 150 to 200 petaflops. Second fastest supercomputer. Okay. Second fastest supercomputer. It is used for medical field research. Used for medical field research. It is used for medical field research, climatic studies, space studies, etc. Medical field research, climatic studies, space studies. So this is all use of Summit. Medical field research, climatic studies, space studies, etc. Second fastest supercomputer, Summit. Third fastest supercomputer also belongs to USA and is called Sierra. Sierra. And the speed of Sierra is 94.6 petaflops. 94.6 petaflops. Used for US Nuclear Security Administration. used for US Nuclear Security Administration. CIRA is used for US Nuclear Security Administration. So when CIRA was developed, already Summit was there. So CIRA never actually occupied the first position. Okay, CIRA was never the fastest supercomputer in the world because Summit was already there. So it became the second fastest supercomputer. Now it is third. After Fugaku, it became the third. So CIRA also belongs to USA. 94.6 petaflops. It is used for US Nuclear Security Administration. Now the fourth and fifth fastest supercomputers are occupied by or held by China. They were once the fastest supercomputers in the world. So the fourth fastest supercomputer in the world is Sunway Taihu Light. Sunway Taihu Light, which belongs to China. Sunway Taihu Light, which belongs to China. So for almost 2 years, Sunway Taihu Light from 2016 to 18, Sunway Taihu Light was the fastest supercomputer in the world. Okay, from 2016 to 18, this was the fastest supercomputer. Now after that, it was replaced by Summit. Now it is replaced by Fugaku. So Sunway Taihu Light is the fastest supercomputer in the world. Speed is 93.01 petaflops. 93.01 petaflops. And it is also used for climate sciences, climatic studies, climate studies, advanced manufacturing, marine forecasting, etc. So these are the uses. Sunway Taihu Light belongs to China. Speed is 93.01 petaflops. It is used for climatic studies, advanced manufacturing, marine forecasting, etc. So before Sunway Taihu Light, for almost 3 years, the top position was held by Tianhe 2, which again belongs to China. Tianhe 2. So the speed of Tianhe 2 is 33.86 petaflops. Speed is 33.86 petaflops. And it is used by the Chinese government for its security applications. It is used for government security applications. Used for government security applications. So these are the fastest supercomputers in the world. Now we will come to the fastest supercomputers in India. So Sunway Taihu Light, nothing much to see. Fastest supercomputers in India or Indian supercomputers. Indian supercomputers. Indian supercomputers. So which is the fastest supercomputer in India? Any idea? Fastest supercomputer in India? So in many of you might have read, if you have read about supercomputers computing, Pratyush was the fastest supercomputer in India. But again in October 2020, this was replaced by a new supercomputer which was developed. Yes, Tianhe 2 is the fifth fastest supercomputer in the world. Tianhe 2 is the fifth fastest supercomputer. Once it occupied the first position, now it is the fifth. So Indian supercomputers, Pratyush was the first, but in October 2020, we developed a new supercomputer called Param Siddhi, which is the fastest supercomputer in India now. Param Siddhi. Param Siddhi. So in October 2020, CDAC, Center for Development of Advanced Computing. Center for Development of advanced computing is CDAC. So in October 2020, Center for Development of Advanced Computing, CDAC, commissioned the largest HPCAI, that is high performance computing and artificial intelligence. HPCAI, high performance computing and artificial intelligence. High performance computing and artificial intelligence. So this is an artificial intelligence enabled supercomputer. So high performance computing and artificial intelligence supercomputer called Param Siddhi. So in October 2020, this Param Siddhi was commissioned by CDAC. So it is a high performance computing artificial intelligence supercomputer. Now, can you make a guess what will be the speed of the supercomputer? It is India's fastest supercomputer. Any idea what will be the speed of the supercomputer? Any guesses regarding the speed of the supercomputer? Type something. Any guesses is fine. Move your hands, take your phone, type something, take your laptop. Yes, that is a good answer. It is less than 33.86 petaflops because fifth fastest supercomputer is Tianhe and its speed is 33.86 petaflops. So definitely less than that. Correct. Now make a guess. $10 petaflop, 20 petaflops. So there are two speeds for Param Siddhi. There is R peak and R max. R peak and R max. So R peak is the maximum speed it can achieve or attain. So this is 5.2 petaflops, but it has not achieved this 5.2 petaflops. It has achieved only 4.6 petaflops, which is R max. The speed which it has achieved is R max, which is 4.6 petaflops. So R peak, the processing speed, no, not teraflops. Don't underestimate us. It's not in teraflops, still petaflops. So the R peak, the theoretical maximum possible speed, R peak is 5.2 petaflops. R peak is 5.2 petaflops. And R max, the speed which it has achieved, is 4.6 petaflops. 5.2 and 4.6. So there is generally a list of top 500 supercomputers in the world, which is released every year. And only 2 supercomputers are there from India in the top 100. Okay. So one is this Param Siddhi, which occupies 63rd position in the top 5. And this, you don't have to remember this rank because this rank will keep changing every year. So currently Param Siddhi occupies 63rd position. Only 2 supercomputers are there in the top 100. And in the top 500, we have only 3 supercomputers. So in the top 500 fastest supercomputers in the world, we have only 3 supercomputers. So Param Siddhi occupies 63rd position in the top 500. Okay. And this helps in, Param Siddhi helps in deep learning. Param Siddhi helps in deep learning. So deep learning is a kind of artificial intelligence, which we will discuss later also. Deep learning. So just for understanding, you can write deep learning is an artificial intelligence function. Deep learning is an artificial intelligence function which mimics the working of human brain. Which mimics the working of human brain. Which mimics the working of human brain. We will discuss about deep learning later. So there are different types of artificial intelligence: machine learning, deep learning, adaptive learning, etc., which we will discuss in artificial intelligence. For the time being, understand Param Siddhi is capable of doing deep learning. Okay, deep learning, which can be done. Now the second fastest supercomputer in India is called Pratyush. Pratyush. So this was the fastest till October 2020. Now it is replaced by Paramsiddhi. So Pratyush is the second fastest supercomputer in India. Second fastest supercomputer in India. And in the top 500, it occupies 78th rank. Last year, I think it occupied 78th rank. Next year, it can again vary. Okay. So Pratyush, second fastest. It is developed by Indian Institute of Tropical Meteorology. Developed by Indian Institute of Tropical Meteorology. Developed by Indian Institute of Tropical Meteorology. See, generally supercomputers when developed, it will be funded by, or the money will be given by a particular ministry. Like CDAC is the research wing of Ministry of Electronics and IT. So similarly, any guesses who actually funded Pratyush? Any idea who actually, which ministry funded Pratyush? It is developed by Indian Institute of Tropical Meteorology. Any idea which ministry funded Pratyush? Obviously, when it is tropical meteorology, it is funded by Ministry of Earth Science. It is funded by Ministry of Earth Science. It is funded by Ministry of Earth Science. Again, it is in the tropical meteorology department. So this is exclusive supercomputer. Yes, good. It is funded by Ministry of Earth Science, and it is an exclusive supercomputer. It is an exclusive supercomputer used only for climatic studies. It is an exclusive supercomputer used only for climatic studies. It is an exclusive supercomputer used only for climatic studies. And the speed is around 4 petaflops. Speed is 4 petaflops. And this is operated in Pune. Pratyush is operated in Pune. Indian Institute of Tropical Meteorology, developed by Indian Institute of Tropical Meteorology, funded by Ministry of Earth Science. It is an exclusive supercomputer used for climatic studies. Location is in Pune, and this is the first supercomputer India developed which functions in the petaflop range. Okay, it is our first petaflop supercomputer, and exclusively used for climatic studies. Okay, and in the list of top 500 supercomputers, it occupies 78th position. Not relevant, but just I told. Now, next supercomputer is Mihir. Pratyush and Mihir. Mihir. So currently, the third fastest supercomputer in India. Third fastest supercomputer in India. Again, developed by Indian Institute of Tropical Meteorology. Developed by Indian Institute of Tropical Meteorology. Developed by Indian Institute of Tropical Meteorology. Funded by Ministry of Earth Science. Funded by Ministry of Earth Science. Funded by Ministry of Earth Science, and this is also exclusively used for, it is also exclusive supercomputer used for climatic studies. Exclusive supercomputer used for climatic studies. Mihir is an exclusive supercomputer used for climatic studies. So now you see we have two supercomputers which are used for climatic studies. We have Pratyush and Mihir. And we had discussed about something called inherent parallelism, where two supercomputers can be clubbed together, and if needed, they can be used for the specific task. So here, Pratyush and Mihir, Pratyush and Mihir can be integrated. Can be integrated based on the requirement. Pratyush and Mihir can be integrated based on the requirement. And it will achieve a speed of 6.8 petaflops. It will achieve a speed of 6.8 petaflops. So now tell me what is the speed of Mihir. So Pratyush is 4 petaflops, Mihir will be 2.8 petaflops. The speed of Mihir is 2.8 petaflops. So when you integrate Pratyush and Mihir, we'll get a speed of 6.8 petaflops. Integrating Pratyush and Mihir to obtain a speed of 6.8 petaflops, where speed of Mihir is 2.8 petaflops. Where speed of Mihir is 2.8 petaflops. See, only 4 countries in the world have exclusive supercomputers for climatic studies. Only 4 countries in the world have exclusive supercomputers for climatic studies. USA, UK, Japan and India. USA, UK, Japan and India. So in defense, wherever you took, there was USA and Russia. Russia is not much interested in either do not have the interest or they do not have the know-how in supercomputing. But when we come to supercomputing, most of the things you will find USA, Japan and China. Okay, most of the things they will be there. But yeah, here exclusive supercomputers for climatic studies, USA, UK, Japan and India. Only 4 countries in the world have exclusive supercomputers for climatic studies. Now, before going to the names of other supercomputers in India, we will discuss the National Supercomputing Mission. So next we will discuss National Supercomputing Mission. National Supercomputing Mission. It was approved in April 2015. National Supercomputing Mission approved in April 2015 with an outlay of 4,500 crores. With an outlay of 4,500 crores for a period of 7 years. For a period of 7 years. So almost 7 years is going to end next year, but still we are far away from reaching the objectives anyhow. So this was started in 2015. Initially funding and all was very less. Even now after COVID, I don't think much funding will come. But recently a press release was there regarding this mission, etc. We'll discuss that. So it was approved in April 2015 with a funding of 4,500 crore and period was 7 years. The objective was to create a cluster of 70 supercomputers. The objective was to create a cluster of 70 supercomputers connecting various academic and research institutions across India. Connecting various academic and research institutions across India. So different IITs, NITs, research institutions, labs, all of them will develop supercomputers. This was the plan. And then all of them will be integrated over a network. Okay, so this was the plan. So it is implemented by National Supercomputing Mission is implemented by Department of Science and Technology. Implemented by Department of Science and Technology and Ministry of Electronics and IT. And Ministry of Electronics and IT. Implemented by Department of Science and Technology and Ministry of Electronics and IT. 70. Create a cluster of 70 supercomputers. 70. Connecting various academic and research institutions across India. Implemented by Department of Science and Technology and Ministry of Electronics and IT. And Ministry of Electronics and IT through CDAC. Through CDAC and IISc Bangalore. Through CDAC and IISc Bangalore. CDAC is in Pune. Through CDAC and IISc Bangalore. Supercomputers will be networked. Supercomputers will be networked. So this 70 supercomputers will be there. They will be networked on National Supercomputing Grid. They will be networked on National Supercomputing Grid. They will be networked on National Supercomputing Grid over the National Knowledge Network. over the national knowledge network. That is NKN, National Knowledge Network. We already have a national knowledge network. So national knowledge network connects, national knowledge networks connects academic institutions and R&D labs, connects academic institutions and R&D labs over high-speed network, over high-speed network. So under this national knowledge network, we are planning to establish a national supercomputing grid. So 70 supercomputers will be established in and around, and all of them will be clustered. All of them will be connected over national supercomputing grid. So this is the national supercomputing or its mission. So this national supercomputing mission has three phases. It has three phases. Phase one, which started in 2015. Phase one, parts of supercomputers will be imported. Parts of supercomputers will be imported and assembled in India. Parts of supercomputers will be imported and assembled in India. They will be imported and assembled. So we do not have any parts which we create by ourselves. We'll import this part and assemble it in India. So phase one is almost over. Okay. So we have developed 6 supercomputers under this phase one. And the first supercomputer built under this national supercomputing mission is Param Shivai. Param Shivai. The phase one, first supercomputer built under national supercomputing mission was Param Shivai, which was developed by Banaras Hindu University, BHU Varanasi. It was developed by BHU Varanasi. And it had a speed of 833 teraflops. 833 teraflops. Param Shivai. Then under phase one, we developed another supercomputer. See, all the supercomputers have the prefix Param. So Param Shivai was there, Param Shakti, Param Brahma, Param Shakti, Param Brahma. All these are supercomputers developed under phase one. So here the prefix supercomputer. Okay. So Param Shivai, Param Shakti, Param Brahma. Param Shakti was developed by IIT Kharagpur. This was developed by IIT Kharagpur. Param Brahma was developed by Acer Pune. So again, I'm not giving you the speed, etc. Not relevant. No speed, etc. If you want, you can learn, but not relevant. I'm not giving the speed. So Param Shakti, Param Brahma is there. So at the end of phase one, we had a total supercomputing capability of 6.6 petaflops. We developed almost 6 supercomputers in the phase one. 6 supercomputers were developed, and we had a supercomputing capacity of 6.6 petaflops. 6.6 petaflops after phase one. 6.6 petaflops. Now phase two. Phase two, 60% components will be indigenous. 60% components will be indigenous. Now recently in October, PIB, there was a press note which said by April 2021, 8 more institutions will be equipped with supercomputing facilities. Okay. So by April 2021, under phase 2, by April 2021, 8 more institutions will be equipped with supercomputing facilities. 8 more institutions will be equipped with supercomputing facilities. It is still not over. Phase 2 is undergoing. So by April 2021, 8 more institutions will be equipped with the supercomputing facilities. And at the end of phase 2, we are expected to have a total supercomputing capability of 16 petaflops. After phase 2, we will be having a total supercomputing capability of 16 petaflops. 16 petaflops. And we have started phase 3. Phase 3, where there will be fully indigenous supercomputers. Phase 3 will have fully indigenous supercomputers. Phase 3 will have fully indigenous supercomputers. And in October 2020, MOU was signed with 10 leading institutions. MOU was signed with 10 leading institutions to establish manufacturing and assembly units of supercomputers. To establish manufacturing and assembly units for supercomputers. To establish manufacturing and assembly units for supercomputers. So an MOU signed with 10 institutions, 9 IITs and NIT Trichy, government has signed MOU. So they will be establishing manufacturing and assembly units for supercomputers. So obviously, by the end of phase 3, we are expected to have a supercomputing facility we are expected to have a supercomputing capability of 45 petaflops. Supercomputing capability of 45 petaflops. So once phase 3 is over, our supercomputing facility is expected to reach 45 petaflops. Now, what are the advantages of National Supercomputing Mission? Advantages of National Supercomputing Mission. See, we have reached only 6.6 petaflops. We are trying to reach 16 petaflops. We might reach 45 petaflops. This is the supercomputing capability we are having. If we take the world's strongest supercomputing nations, USA have a total supercomputing capability of 668.7 petaflops. 668.7 petaflops. And China and Japan have a supercomputing capability of 593.7 petaflops. It will vary because as you develop new and new supercomputers, this will definitely vary, but still 670 or near to 700 petaflops is the capability of USA. Near to 600 is the supercomputing capability of China and Russia, and India is still struggling at 16, 20, 40, 45. So we have a long way to go. So through this National Supercomputing Mission, India should be reaching the league of advanced nations. This is what we are targeting. So the mission has potential. First advantage, the mission has the potential to bring India into the league of. The mission has the potential to bring India into the league of advanced supercomputing nations. Advanced supercomputing nations. So again, if you take the list of 500 fastest supercomputers in the world, China has 229 supercomputers. Okay, this is just facts I am telling for information. You don't have to mug up. China has 229 supercomputers. US has 121 fastest supercomputers. And Japan has 34. The top 500, Japan has 34. India has just 3. This is the number of fastest supercomputers in the top 500. So this also has to change. So the mission will push India into the league of elite supercomputing nations. This is one of the missions or advantages of this supercomputing mission. Second, first one, it has the potential to bring India into the league of elite supercomputing nations or advanced supercomputing nations. Second, see, if you want to have a supercomputer, if you want access to a supercomputer, you will have to go to maybe Pune or Nagpur, where a supercomputer is there, or IIC Bangalore. Only these places have supercomputers. So suppose I want to do some analysis, whether I'm doing my research, I'm doing my PhD, or I am a entrepreneur, okay, and I want to find some, I want to do some analysis regarding my manufacturing, production, etc. And it is a very complex calculation. I have no way to use a supercomputer. So once this national supercomputing mission becomes a success, there will be supercomputers in all major institutions throughout the country. So all NITs, IITs, all will be having supercomputers. So the accessibility to supercomputer will increase. So this is the second point, second advantage. Accessibility to supercomputers, accessibility to supercomputers at affordable rates. Accessibility to supercomputers at affordable rates. Third, it will enhance the quality and quantity of R&D. It will enhance the quality and quantity of R&D in our higher education institutions. In higher education institutions. Enhance the quality and quantity of R&D in higher education institutions. And it can be used to solve, fourth point, it can be used to solve multiple current and future challenges. Multiple current and future challenges. Multiple current and future challenges affecting our country. Like weather predictions. This is application also. Climatic modeling. Weather predictions, climatic modeling. Atomic energy simulations. Atomic energy simulations. Then disaster simulations. Disaster simulations. Defense, healthcare, multiple areas, multiple problems, defense, healthcare. So to address the current challenges and future challenges in many of these areas, we can use supercomputers. To address challenges in many of these areas, we can use supercomputers. So these are all the advantages of National Supercomputing Mission. So we have started phase 3. More updates will come about supercomputers. Maybe we'll develop faster supercomputers. Obviously, we'll develop faster supercomputers. So remember the names. Whenever Paransiddhi is getting replaced by some other supercomputer, do remember the names. So National Supercomputing Mission can be a mains question also. Because I told you so far no questions have come from the ICT in the mains. Definitely UPSC will ask questions from ICT in the mains examination. Whether it is supercomputing, quantum computing, or technology 3G, 4G, 5G, or whether it is going to be big data, Internet of Things, artificial intelligence, but definitely you will get questions. So this is the supercomputing mission. Now, a couple of more things. First, we will discuss supercomputers and COVID. So supercomputers were used during COVID. Supercomputers and COVID. So actually it was used by USA, the Summit, the second fastest supercomputer we discussed. Summit was used by USA to find chemicals which can fight COVID. So there is a lab in USA called Oak Ridge National Lab. They use the Summit to find compounds that can actually fight COVID-19. So they started with almost 8,000 compounds and reached a list of 77 drugs which can actually fight COVID. Okay, so this actually helped the discovery of the drug, etc. So supercomputers were used in the development of drugs. So USA, supercomputers and COVID, USA established COVID-19. USA established COVID-19 high performance computing consortium. USA established COVID-19 high performance computing consortium to create compounds that might prevent or treat COVID. that might prevent or treat COVID. Oak Ridge National Lab. Oak Ridge National Lab used the Summit supercomputer. Oak Ridge National Lab used the Summit supercomputer. Oak Ridge National Lab used the Summit supercomputer to look into the compounds. That are already available in the market. To look into the compounds that are already available in the market to combat COVID-19. That are already available in the market to combat COVID-19. They started with 8,000 compounds. They started with 8,000 compounds and came out with a list of 77 drugs. And came out with a list of 77 drugs that showed promise. And came out with a list of 77 drugs that showed promise. So this is one application of supercomputers during the time of COVID. So this year there was one mains question where how technology helped in fighting COVID, etc. One of the examples where it is not just drug discovery, multiple areas you can use technology, health, education, drug discovery, testing, multiple areas it is there. So supercomputers were also used in amidst COVID. Now I want to discuss one institution, CDAC. CDAC, Center for Development of Advanced Computing. Center for Development of Advanced Computing. It is an R&D organization under Ministry of Electronics and IT. It is an R&D organization under Ministry of Electronics and IT. Established in 1988. Established in 1988. An R&D organization under Ministry of Electronics and IT. Established in 1988 to develop indigenous supercomputers. To develop indigenous supercomputers. To develop indigenous supercomputers. So India is actually getting supercomputers from US called Cray supercomputers. So this was a supercomputer we were obtaining from US, but US stopped importing this supercomputers to India. So we wanted to develop our own supercomputers. So that is why we established organization called CDAC in 1988. And the first supercomputer which was indigenously built is Param 8000. So CDAC actually built Param 8000. The first indigenous supercomputer. So this at time this had a speed of 5 gigaflops. It had a speed of 5 gigaflops. Speed of 5 gigaflops, which was the second fastest supercomputer in the world at that time. It was the second fastest supercomputer in the world at that time. Second fastest supercomputer in the world at that time. Okay, so now few more supercomputers name we will discuss randomly. So there is a supercomputer called Param Shawang. So there is a supercomputer Param Shawang, which is developed by various IITs. Param Shawang, developed by various IITs. It's actually a very small supercomputer. So it is the world's first desktop model supercomputer. World's first desktop model supercomputer. So if you have seen the supercomputers, it will not be like a desktop model. The screen will be pretty big, a lot of processors. It is pretty huge. So this is like desktop model supercomputer, and the speed is 3 teraflops. 3 teraflops. It's a supercomputer developed by various IITs. World's first desktop model supercomputer. Speed is 3 teraflops. Speed is 3 teraflops. Then the India is actually developing a supercomputer with France called Bull Sikova. Bull Sikova. India is developing a supercomputer, Bull Sikova. It's a joint development of India and France. Joint development of India and France. Joint development of India and France. Speed of 10 petaflops. Joint development of India and France. Speed of 10 petaflops. Speed of 10 petaflops. And it will be used for coordinated academic research. It will be used for coordinated academic research. India and France will be using it for academic research. Bull Sikova. Then there is a supercomputer called Spinnaker. Spinnaker, which is developed by EU, European Union. So this is using artificial intelligence. This supercomputer is using artificial intelligence, and it can generate, Spinnaker can generate artificial brain signals. So it can generate brain signals by using the supercomputer. It can generate brain signals similar to human beings. It can generate brain signals similar to human beings. It can generate brain signals similar to human beings. And hence can be used to cure. Hence can be used to cure Alzheimer's disease, Parkinson's disease, etc. Alzheimer's disease, Parkinson's disease, etc. So it happens due to the problems in our nerves, brains, network system. So far no cure is there. If Alzheimer's come, Parkinson's come, cannot be treated. Now we are developing supercomputers which can actually generate the signals from the brain, and it will be like a treatment to or it can be a cure to Alzheimer's disease, Parkinson's disease, etc. So this is some supercomputers. Now there are some future supercomputers. There are some future supercomputers which is under development, and in next couple of years obviously this will come out. So US is developing a supercomputer called Frontier. US is developing Frontier and Aurora. US is developing Frontier and Aurora, and China is developing Tianhe 3. China is developing Tianhe 3. USA is developing Frontier and Aurora. All of them will have speed in exaflops. Now petaflops, next level exaflop is 10 raised to 18 instructions per second. So these supercomputers are expected to perform in exaflops. Okay. So petaflops, we are done with petaflops. 415 petaflops is currently the fastest. These supercomputers will perform in exaflops. So again, once more information comes out, do take a note of them. These are going to be the world's next fastest supercomputers: Frontier, Aurora, Tianhe 2, etc. These are all future supercomputers. These are all future supercomputers. So Pratyush, Mihir, etc. Next topic is, next computing terminology is quantum computers. Quantum computers, which we'll discuss after a break. If you have any doubts, you can ask. Quantum computers. So as I told, we will be having 3 more sessions from my side. After this session, 3 more extra sessions where we'll be discussing 2 more sessions. 2+ sessions we'll finish ICT, and half session, between half and 1 session, we'll be discussing green technology. So the topics I'll be discussing. No doubts? Can take 5 minutes break, come back. So after Parambrahma 1, I told Parambrahma 1 was developed by Acer Pune, and India will have a supercomputing speed of 6.6 petaflops. After phase 1, we are expected to have a supercomputing speed of 6.6 petaflops. Spinnaker is developed by European Union, not a joint development. Bull Sikova is a joint development of India and France. Spinnaker is developed by EU. It is a supercomputer developed by EU. Okay, so next is quantum computing. So quantum computers are actually superior to supercomputers in its performance. Okay, and why it is superior is something which we have to know. Quantum computers are superior to supercomputers, and it is only under development. No, there is no exact quantum computers which are operational and which is giving results. Countries, Google have claimed, even recently China claimed that they have achieved quantum computing facilities. So it is still under development, and it is going to rule the world in the forthcoming generation. So it is superior to supercomputers in multiple aspects, not just in performance, even in security aspects. Quantum computers are superior to supercomputers. So we have to wait and watch how quantum computers are going to evolve and how they are going to rule the world. So you can just write quantum computing superior to supercomputers in its performance, superior to supercomputers in the performance. Quantum computing superior to supercomputers in performance, and it is still under development. Still under development. See, there are certain features of quantum computers which enable them to perform it at a very high speed. There are certain features. So the first feature is called superpositioning. First feature is called superpositioning. See, what is superpositioning? Before going to superpositioning, you should understand how information is stored in a computer. So information is stored as bits. Okay, in all computers up to supercomputers, information is stored as bits. That is, the information is stored either as 0 or 1. You would have studied in schools, like, no, computer does not understand the language you speak. So the language has to be translated into a language called binary system, where it should be fed in such a way that computer understand it. So this is fed as bits. And what represent these bits? The bits are represented by electrons. So this 0 and 1 is represented by electrons. So electron will have a value of either 0 or 1. When we come to quantum computers, these electrons are replaced by fermions. Fermions are also called angel particles. And the property of fermion or angel particle is that, see, in the case of bit, and if we have an electron, so this electron can be either 0 or 1. It cannot be both. But when we come to quantum computers, we take a fermion. Fermion can be both 0 and 1 simultaneously. It can be both 0 and 1 simultaneously. That means it can store more information at one time. Okay, an electron is either 0 or 1. So a fermion can be 0, 1, or both of them together. So that means it can process more information, it can store more information. This is called quantumness or quantum computing, where a material exhibits two different properties simultaneously. Okay, this is called quantum. So this property of this here we represent it as bits. Here we represent this as quantum bit, qubit. This is called qubit. This fermion is called qubit. So this qubit can exhibit two different properties simultaneously, and this superpositioning is the property of this qubits to have multiple values simultaneously. It can exhibit more than, it can store more than one value simultaneously, and this is called superpositioning. So you can write superpositioning, the properties of quantum computers. Properties of quantum computers. First is superpositioning. Property of qubits. I'll explain qubit. Just write superpositioning. Then you'll write the explanation. Property of qubit to have its value as 0 or 1. Property of qubit to have its value as 0 or 1 or combination of both. 0 or 1 or combination of both. Under that you write as a note. In normal computers up to supercomputers, information gets stored as bits. In normal computers up to supercomputers, information gets stored as bits. That is either 0 or 1. Information gets stored as bits. That is 0 or 1. Electron represents bits. In quantum computers, information gets stored and processed as qubits. Information gets stored and processed as qubits or quantum bits. It gets stored and processed as qubits or quantum bits. Fermions. They're also called angel particles. Fermions or angel particles. Represents the qubits. It can hold the value of qubit. Qubit can hold the value of 0. Qubit can hold the value of 0 or 1. Or combination of 0 and 1. Qubit can hold the value of 0 or 1 or the combination of 0 and 1. So quantum means material exhibits two different properties simultaneously. Quantum means material exhibits two different properties simultaneously. Material exhibits two different properties simultaneously. So this is superpositioning. Superpositioning is the property of quantum bits to have both 0 and 1 simultaneously. So it will exhibit more than one property at one point of time. This is superpositioning. Second property is called entanglement. Entanglement. Just write the definition, then I'll explain. Entanglement. It is the way of assigning values to qubits. Based on previous reference. Based on previous reference in the same word. On a random basis. Based on previous reference in the same word on a random basis. Way of assigning values to qubits based on previous reference in the same word on a random basis. So qubits can have value of 0 or 1, right? So suppose take a word Ganga. I'm taking this word Ganga. So for G, no, I'll assign the qubit will get assigned some value. Suppose the qubit is taking value of both 0 and 1. It is taking value of both 0 and 1. Now comes A. A is as randomly assigned value of 0. N randomly assigned value of 1. This is qubit. It is randomly we are assigning value. Now again a G comes. In the same word, a G comes. So there is a previous reference that G is both 0 and 1. So this will be taken as 0 and 1 based on the previous reference in the same word. And when A comes, already there is a previous reference, so it will be 0. So this is called entanglement. In a same word, based on the previous reference, value will be assigned. And how this is assigned? Randomly. The value initially is assigned randomly, and thereafter when the same word comes, okay, when the same qubit comes, values will be based on the previous reference. This is only in this word. Now take another word, Raja. So Raja has an A. Okay, so this A need not be 0. Based on Ganga A was 0, here it can be 1 or 0 and 1 simultaneously. Okay, here the value will be different. So in the same word, based on the previous reference, value will be assigned. This property is called entanglement. This is the second property of qubits. And now the third property is called eavesdropper free. Eavesdropper free. See, eavesdropper is a third person or an, is like a middleman. Suppose I am doing a transaction, I am doing a banking transaction, and how will you assure that there is no other person while this transaction is happening? I'm transferring money to some other people, or I'm doing any digital transaction. How will you ensure that there is no extra person, there is no any eavesdropper in the transaction? For normal computers, it is not possible to do this. But for quantum computers, even if an eavesdropper is there, it is useless, because what will happen? Quantum computer will understand that there is an eavesdropper, and suppose I'm entering password 1234. If when it understands that there is an eavesdropper, it will randomly shift characters. So I am typing 1234, but quantum computer will enter it as 2314. It will enter it as 2314. So what will happen? Password will go wrong. Why it has, because of this property of superpositioning entanglement, it is possible for a quantum computer to reverse the character. So if it understands that a third person is present in the transaction, it will automatically reverse the character, and no eavesdropper can access any information. So it will automatically reverse the character, and we will get a message that access is denied. We will not be able to do the transactions, and message will be sent to the bank and the user about unusual activity. Message, we will get the message, bank will get the message that there is some unusual activity which is happening, please take care of it. So this is what happens in quantum computers. So it is a highly secure transaction, and no third party can be a part of it. No third party can intervene in the transaction. See, for normal transactions, day-to-day activities, it is not relevant. But assume a highly encrypted transaction or highly secret transaction like banking transactions or defense. We are sending some secret messages. It should not be decrypted, or it should not be third person should not be there in that message at all. So for all this, we can go and use quantum computers. So this is the one of the applications of quantum computers. Eavesdropper free. You can write eavesdropper. Eavesdropper is a third party or intermediate person. Third party or intermediate person. Eavesdropper is a third party or intermediate person. In normal computers, if a third party is present, it will be unnoticed. In normal computers, if a third party is present, it will be unnoticed. In normal computers, if a third party is present, it will be unnoticed. But in quantum computers, eavesdropper cannot perform any attack. as the quantum computer will reverse the characters. In quantum computers, eavesdropper cannot perform any attack. As the quantum computer will reverse the character, quantum computer will reverse the character and access will be denied. Quantum computer will reverse the character and access will be denied. Access will be denied. And a message of unusual activity will be sent. And a message of unusual activity will be sent. So quantum computing is a highly secure computing technology. So quantum computing is highly secure. So quantum computing is highly secure. Quantum computing is highly secure and can be used in quantum computing is highly secure and can be used in banking sector, defense, space communication, etc. Banking sector, defense, space communication, etc. So this is the third property. Fourth is inherent parallelism. Inherent parallelism. We already discussed about inherent parallelism in supercomputers. What is inherent parallelism? More than two supercomputers or more than one quantum computers can be connected to perform a specific task. So this is possible for quantum computers also. More than one quantum computers can be connected. More than one quantum computer can be connected to perform a single task. To perform a single similar task. Single similar task. And then quantum computers are also task specific. They are also task specific. That is, they perform one task at a time. They are task specific. That is, they perform one task at a time. They perform one task at a time. Okay, so these are some properties of quantum computers: superpositioning, entanglement, it is eavesdropper free, there is inherent parallelism, and they are task specific. Now regarding the speed of quantum computers, supercomputers, if it was performing in 2 billion instructions per second, quantum computers will perform 2 to 5 billion instructions per second. Quantum computers will perform 2 to 5 billion instructions per second. So this is going to the speed of quantum computers, 2 to 5 billion instructions per second. And there is a term called quantum supremacy. There is a term called quantum supremacy. There is a term called quantum supremacy. That is, quantum computers entanglement, I told, it is a way of assigning values to the qubits based upon previous reference in the same word. Based on previous reference in the same word on a random basis. So quantum supremacy is quantum computers solving problem. Quantum computers solving problem that cannot be expected of a classical computer in normal time. Quantum computer solving a problem that cannot be expected of a classical computer in normal time. So this action which is done by quantum computers will not be or cannot be done by a normal computer in normal time. So quantum computers, if the normal computer take 10 years to solve the problem, quantum computers will solve it in seconds or minutes. So this is quantum supremacy. So once quantum computers come into existence, we will have this concept of quantum supremacy. So Google have claimed that they have achieved quantum supremacy, by a project called Project Sycamore. So Google has claimed that they have achieved quantum supremacy by a project called Project Sycamore. So Sycamore is the name of the qubit processor they used. So they said they have used a qubit processor, or like the name of the qubit processor was Sycamore, and Google claimed that they have achieved this quantum supremacy. Okay. So again, now more and more countries will claim quantum supremacy. So keep a note of any quantum computers which is getting developed, any quantum developments which is happening in the world. Keep yourself updated. So obviously this is a developing thing, and more names, terminologies, etc. will come. The basics will be the same, but new names, new quantum computers will come into existence. See, all properties of quantum computers, including superpositioning, entanglement, is used for process. You see, and superpositioning, it can have both values. By entanglement is a property by which values are assigned to the words. Okay, so based on previous reference, it will be assigned. This is a property of quantum computers. Superpositioning is a property by which it can take values 0, 0, 1, and entanglement is how the values are getting assigned. So all these are properties of supercomputers which help them to perform tasks at a very fast, complex speed. So if in the same word, if you are assigning multiple values, the processing will be difficult. Now quantum computers have a feature where already if A is assigned 0, all A's in the word will be 0, which will help it in increase in its processing speed will again increase. So all these properties will help in the faster processing, faster speed of quantum computers. So this is all about quantum computing. Now India has a mission. India recently, in the last budget, we came out with a quantum computing national mission on quantum technologies and applications. We came out with a mission called National Mission on Quantum Technology and Application. National Mission on Quantum Technology and Application. Not just for quantum computing, all quantum applications. Okay, all quantum applications, we have come out with National Mission on Quantum Technology and Applications, announced in 2020 budget. This was announced in 2020 budget. 2020 budget with an outlay of 8,000 crores. With an outlay of 8,000 crores. So it will include development of quantum computing. It will include development of quantum computing, quantum communication, quantum artificial intelligence. All these things will be taken on this mission. See, more details are yet to come out. There is some paper which was submitted in, I think, March or something. February, March, some paper has been submitted regarding this mission. More details will obviously come out soon regarding how we are going to implement it, what we are going to do in this mission. So again, update yourself. Whatever information is coming about this mission, update yourself. This can be prelims as well as mains question. National Mission on Quantum Technology and Application. So announced in the 2020 budget. It will focus on all areas of quantum technology, quantum computing, quantum communication, quantum artificial intelligence. Wherever we are using this quantum techniques, it will be used. Now there is one more mission which was started by Department of Science and Technology in 2018. So in 2018, Department of Science and Technology launched Quest, Q-U-E-S-T, Quest, Quantum Enabled Science and Technology. Quest is Quantum Enabled Science and Technology. Quantum Enabled Science and Technology. Quest is Quantum Enabled Science and Technology. It is across 51 organizations. Research project across 51 organizations. This was Quest. Research project on quantum technology. Research project on quantum technology across 51 organizations. Research project on quantum technology across 51 organizations. This was called Quest, started in 2018 by Department of Science and Technology. Right. So this is regarding quantum technology, quantum computing. Now next is, after quantum we'll come to cloud computing. The third computing terminology is cloud computing. Cloud computing, again, you would have heard, even if you have not heard about it, you will be definitely using cloud computing. Example of cloud computing, one example is Google Drive. So you will be definitely using Google Drive to share things, upload things, etc. It's an example of Google quantum cloud computing. Then all the OTT platforms, including WhatsApp, Netflix, Amazon Prime, all of them are using cloud computing. Okay, means the information is shared not in your personal phone. You are watching something on Netflix, is it saved in your phone? No, you are using the something which is stored somewhere else, right? And Google Drive, you are uploading things to Google Drive, where it is getting saved in your system? No, it is getting served in some storage space somewhere in the world, you don't know where. Maybe it is in US, maybe it is in Europe. So it is getting stored in some server somewhere, right? So this is called cloud computing. Cloud computing is not just about storage, but you can store data, you can process data, you can perform multiple things using this cloud computing. So next is cloud computing. Yes, Google Pictures, Amazon Web Services, yes, all are examples of cloud computing, correct? So cloud computing, computing methodology which makes users store, manage and process data, by using virtual storage area, irrespective of user's location and time. Irrespective of user's location and time. So computing methodology which makes the users to store, manage and process data by using virtual storage area irrespective of users location and time. Example Google Drive, Dropbox and OTT services. OTT is over the top services. So you do not require a tele service provider, or you do not require a SIM card to access this service. This is OTT. So WhatsApp, Amazon Prime, Netflix, etc. When you are using it, you do not require a SIM card, right? Even WhatsApp, initially you might need a SIM card. After that, your SIM card the validity might be over, but still you can access WhatsApp. So all these are called OTT services. Service providers who render the service, without having dependency on TSP, that is tele service provider. Without having dependency on tele service provider, TSP, they are called OTT services. So all OTT services uses cloud computing. Fine. Now India has an official cloud computing network called Meghraj. So India's official cloud computing network is called Meghraj. And there is something called DigiLocker. You might have studied about this. DigiLocker comes under Meghraj. We have DigiLocker which comes under Meghraj. So what is the purpose of DigiLocker? To store government documents, certificates. So you can store government documents in either PDF or as doc or as JPG image. So you can store government documents as PDF, doc or JPG, JPEG. So this is how you can store the government documents. The maximum storage is 1 GB. As of now in DigiLocker, you can have a storage of up to 1 GB. And it will be a free account. It will be a free account. Only mobile number and Aadhaar number is required to create an account. Only mobile and Aadhaar number is required to create an account. Mobile and Aadhaar number is required to create an account. So this is India's official cloud computing network, Meghraj, under which we have DigiLocker, where you can actually store all the government documents, certificates, etc. Now, if you are applying for a job somewhere, etc., and you have a DigiLocker account, the company have a DigiLocker access, they can access all your certificates through DigiLocker. You need not carry all the certificates around. Even UPSC can move to DigiLocker. Once you clear the exams, when you go for the interview, there is something called certificate verification, which is still done physically. Now DigiLocker everybody has a DigiLocker account. UPSC can move to DigiLocker. Certificates, everything you want can be uploaded in DigiLocker, verified online. You're using the cloud computing network. So this is DigiLocker. Now there are three basic features in cloud computing, or there are three basic features in cloud computing, or how this is shared. Three basic features. First one is called software as a service. SaaS, software as a service. Software as a service. It represents a customized software. We are sharing a customized software. We are sharing a customized software. And it is mostly used by end users, like you and me. We are end users. We will be using this customized softwares. Example is an MP3 converter. You want something with you to be converted into MP3 or MP3 cutter, or this PDF to doc converter. So when you want to convert something into a PDF into doc, what you will do? You will upload this PDF. It will be converted into doc and sent back to you. Right? So this is all. Do you have the software in your app? No. You can convert it online. You will upload it. It will be converted somewhere in some other server. Somewhere it will be converted, and you will be sent back. And you want to convert a song into MP3, video into MP3. You will upload this, convert it, and then it will be sent back. This is all examples of software as a service, or in some shared server or some shared space, you are using a software. So this is the first feature of cloud computing. Software as a service. Software as a service. So it represents customized software, and it is used by end user. Example, you can write MP3 cutter, converters, etc. MP3 cutter, converters, etc. Second is platform as a service. Software as a service. Second is platform as a service. Platform as a service. So this represents operating system. This represents operating system. It represents operating system, like Windows is an operating system, Linux is an operating system. So this is you will use an operating system which is not in your system or your mobile or your computer. This is used by developers. This is used by developers. Used by developers to develop applications. Used by developers to develop applications. So while developing these applications, you need not use operating system in your phone or computer. You can use access the operating system from some other remote location. Okay, so this is called platform as a service. Platform as a service. And the third feature is called infrastructure as a service. Infrastructure as a service, or IaaS, infrastructure as a service, IaaS. Infrastructure as a service, it represents storage, shared storage. Infrastructure as a service, shared storage. And this is basically used by system administrators and all who have the full control over the storage. Used by system administrators, etc., who have the full storage. This is an example of information infrastructure as a service. So first we have software as a service where you share softwares. Then above that we have platform as a service where you share the operating systems. And then above that we have infrastructure as a service where you share the storage. Okay, so first one is used by end users like us. Then above that platform is used by developers, and then infrastructure is used by system administrators who have entire control over the infrastructure. Okay, so so next, so now the problem with this, what we say, this cloud is that there is no interoperability. Suppose I have some information in what we say Google Drive. Can I access it from iCloud? No. Okay, I cannot access it from iCloud. So the government is coming out with something called a fourth feature called integrated platform as a service, iPaaS. Okay, the government is coming out with an integrated platform as a service. Integrated platform as a service, where there will be interoperability between two cloud sources. Where there will be interoperability between two cloud sources. Interoperability between two cloud sources. Now there is some latest developments in cloud called fog computing and edge computing. Okay, two recent developments in cloud. It is type of cloud computing itself, or it will come under cloud computing. We have fog computing and edge computing. Fog computing and edge computing. So just 1 minute, I'll be back. Okay, so we are going to discuss fog computing and edge computing. So what is this? See, basically, I'll give you one, I'll explain it and then we'll write. So you are accessing, say, Amazon Prime or Netflix, and you are watching a movie in Netflix. So the processor is your mobile phone. And where is the storage? Storage is in some server in USA or wherever, Europe. And from there, you are accessing this. So the distance between storage and processor is quite large, quite long. So what will happen? There is something called buffering speed. Okay. So the buffering speed will depend on two things. One is the speed of your internet service. That is obviously there. Second will depend on the distance between the storage and the processor. As the storage and processor come closer, the buffering speed will definitely increase. Buffering speed will improve. So in fog computing and edge computing, we are moving towards decentralized storages. Instead of one centralized cloud storage in US or UK or wherever in Europe, we are going towards decentralized clouds, and say in every building there will be a cloud storage. I'm just giving you an example. So every building there in your home or in nearby your home, there will be a cloud storages called edge computing. Okay, so companies will be there which will provide edge clouds. So in each building there will be one edge cloud. So as soon as you start buffering this movie, watching this movie from the centralized cloud, wherever it is, it will come to the edge cloud in your house or in your locality. So the distance between the processor and the what we say storage will come down. This will improve the browsing speed. This will improve the buffering speed. So edge computing is the nearest level of storage. Above edge computing, there will be fog computing. Suppose there is one edge computing in for like 20 buildings in a particular area, and this edge computing will have a particular storage capacity. That storage is full. What will happen? Things will be stored in the fog computing. Okay, so edge computing, above edge you will have fog, and above this you will have cloud computing. So one example I'll give you is the CCTV cameras which we use in the roads to monitor the vehicular movement, etc. So each of this CCTV camera will have its own local storage, which is an example of edge. Okay. Now maybe for a particular region, say if you are in Chennai, Anna Nagar region might be having one fog computing. So in Anna Nagar region itself, there will be a lot of cameras, and all of them will have their own storage edge. Above this, there will be what we say for a particular region, Anna Nagar region, there will be some fog, and maybe for entire Chennai there will be one cloud. So this is an example. At the decentralized local level, we will start from edge. Above this there will be fog, and above that there will be what we say cloud. So once the edge memory is full, it will be served in the fog memory or fog computing, and above this it will be served in the cloud computing. So these are three levels of cloud computing. And see, now the distance between the storage and the processor reduces, speed will increase, right? So this is going to be one of the ways by which we will be having greater speed in the 5G technology. So 5G obviously speed is going to be very fast. So this is one of the ways we'll move towards edge computing or edge clouds, where clouds will be there, multiple clouds will be there in a particular locality. So this will tremendously improve the speed of buffering and browsing. So this is example of cloud, fog computing and edge computing. So both fog and edge are examples of cloud computing. Both fog and edge, it will come under cloud computing. This is under cloud computing. This is also under cloud computing. Both are under cloud computing. And in both, storage and processor is kept close to each other. Storage and processor is kept close to each other. Here also storage and processor is kept close to each other. Storage and processor is kept close to each other. Now in edge computing, information will be stored information will be stored in a cloud server. Information will be stored in a cloud server around the system. Around the system in edge virtual storage. Information will be stored in cloud server around the system in edge virtual storage. In edge virtual storage. Processing and storage is near the device. Processing and storage is near the device. Processing and storage is near the device. When edge memory is exceeded, it will be stored to the fog. When edge memory is exceeded, it will be stored to the fog. And when fog memory is exceeded, it will be going to the cloud. When fog memory is exceeded, it will be going to the cloud. And in fog, the processing and storage is done at local area network. Processing and storage is done at local area network, LAN. Processing and storage is done at local area network. So for a particular locality, there will be one fog storage. Not for every building, for a particular region, particular locality, there will be one fog storage. So processing and storage is done at local area network. At local area network. Now there is something called latency time period. What is latency time period? It is nothing but this buffering time. Okay. So for fog, latency time period is reduced. Latency time period is reduced as compared to cloud. Latency time period is reduced as compared to cloud. And for edge, latency time period is lesser than fog. Latency time period is lesser than fog. So fog, it is lesser than cloud. For edge, it is lesser than even fog. Lesser than fog. So latency time period, under this you can write latency time period as a common note. Latency time period is the time required for buffering. Latency time period is the time required for buffering. Latency time period is the time required for buffering, which will depend on the network speed, as well as the distance between, the storage and processor. The storage and processor. Now, see, when every information is streamed from one cloud, okay, there will be lot of data traffic from the single cloud. There will be, around the world, people are buffering, people are watching, things from the same cloud. Whosoever is using Netflix might be using the same cloud. So there will be huge data traffic. Now, when we are going to fog and edge, there will be decentralized clouds. So the data traffic will be reduced. Maybe this cloud, only I am using Netflix. So my speed will be tremendously high because the data traffic, this fog, this edge is serving only me. So the data traffic will reduce. When the data traffic reduces, the processing speed will obviously improve, right? The processing speed will improve, and this is one of the major advantages of edge computing. So in edge computing, the dependency on the cloud will reduce. The dependency on the cloud reduces. The dependency on the cloud reduces, and the data traffic reduces. Dependency on cloud reduces, data traffic reduces, and this improves the processing speed. This improves the processing speed. Now, in all these cases, you should remember that information is stored in remote server, okay, not in your server. So if we take this cloud, edge and fog, so we have a cloud, which is a centralized system. Below cloud, we have fog computing, and below fog, we have edge computing. Below fog, we have edge. So this is centralized. This is centralized, and these are decentralized. This is centralized, and these are decentralized. Fog and edge are decentralized. In all these cases, information is stored in remote server. Even in edge, it is not in your phone or your laptop. It is stored in remote server. In all cases, information is stored in remote server. In all these cases, information is stored in remote server. And in future, there is going to be more dependency on edge. Okay, in future, this is the future technology, still under development. In future, definitely we are going to move towards edge computing. Okay, so definitely it is an expected area of questions in the UPSC. Edge computing, the technology of edge computing, how this operates, etc. is expected. And edge computing will play a significant role in Internet of Things and 5G technology. Edge computing will play a significant role in Internet of IoT devices. It will play a significant role in IoT devices and 5G technology. IoT devices and 5G technology. So this is the basics of cloud computing, edge computing, fog computing. Now the next type of computing is called grid computing. Grid computing. Grid computing. So it is a network of, or it is an interconnected common network of computers. Grid computing is an interconnected common network of computers for performing a single specific task. For performing a single specific task. So, a lot of computers will be there, which will be interconnected, and it will be performing a single task. So, India has an official grid computing network called Garuda. We have an official grid computing network called Garuda, which is basically used for carrying out admissions, recruitment, etc. Garuda is used for carrying out admissions, recruitment, etc. So you might have used it when if you take, there is something called single window admission system these days, right? So admission process happens simultaneously at multiple places, multiple centers, etc. This is done using Garuda platform. This grid computing, where a lot of computers are connected together, and it will perform a single task. So we have an official grid computing network called Garuda, which is used for carrying out admissions and recruitment. And using grid computing, we will have complete transparency. We will have complete transparency with effective utilization of resources. We will have complete transparency with effective utilization of resources. Okay, because all the systems are connected, it will be everything, whatever happening will be transparent. There will be no secrecy, no admission process. If you have to do, it will be a completely transparent process, because the everywhere it will be available, data will be available, and this technology, we will be sharing the resources because it is a connected system. So this is grid computing. Next is called optical computing. Grid computing, then there is optical computing. Optical computing. This is only under development. Optical computing is only under development. And here photons will be used as bits. 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 It will be superior to supercomputers. It will be superior to supercomputers, but inferior to quantum computers. Superior to supercomputers, but inferior to quantum computers. Superior to supercomputers, but inferior to quantum computers. Now the last in computing is green computing. Green computing. Green computing. So far we have been discussing about the performance of computers. So faster, how it is performing. But green computing is not about performance. It is about environment. So technology which makes the user handle the system in a eco-friendly manner. This is called green computing. It is a technology which makes the user handle the system in an eco-friendly way. So energy consumption can be reduced. By switching off the display, switching to dark mode. Switching off the display, switching to dark mode, etc. Switching of the display, switching to dark mode. So when you switch to dark mode, the brightness will come down and it will automatically reduce the energy, right? When we switch to dark mode, this is one of the advantages. It automatically reduces the energy. So this is all about different computing terminologies, different modern computing terminologies. In the next class, we'll start from malwares. So we'll start from malwares in the next class. Any doubts? You can ask. I think White Hat provides more like a service, like it is a service platform. So I think it is software as a service. This, I guess it is software as a service rather than platform. It provides a service. So green computing, is a technology which makes the users handle the system in a eco-friendly manner. Green computing is a technology which makes the users handle the system in an eco-friendly manner. Energy consumption will be reduced. Energy consumption will be reduced by switching off the display, switching to dark mode, to reduce brightness, etc. Switching off the display, switching to dark mode to reduce brightness, etc. So this is green computing. Mandatory sources, there is no mandatory sources. Class notes, first thing. Second, now if you have not read NCRTs, please don't read NCRTs now. It is not the time to read. Start afresh from NCRTs. So if you have read any source, please do read that. Class notes plus do tests. Now, if you have read any book, please do read that. Again, if when you are reading something, if you have some doubt, no, you can refer some books for further clarity. Apart from that, don't read any books. If you have already read NCRTs, try to revise that. If you have not read NCRTs, please don't read that. Then do as many number of tests. Third is current affairs. So current affairs, you can refer any one source. If you have been reading monthly magazines, revise that. If you have not been reading monthly magazines, revise say 365 magazine. Okay. Whatever you are reading, revise 3 times, minimum 3 times. Please do not read any new source now. Only whatever you have read, please revise them. And question papers, try to solve as many question papers as possible and revise these question papers. Again, I'm not asking you to sit for 2 hours and solve 100 questions. In a question paper, maybe 50 questions you will be knowing. 50 questions you will not be knowing. Revise those 50 questions which you don't know 3 times. So this is what I'll suggest for science and technology from a prelims perspective. Sources, class note, current affairs, any month magazine, and third, question papers, revise these question papers. Even our academy, try to solve as many number of question papers as possible. Fine. Anything else? So we'll wind up the session. I'll meet you in the next class. Thank you. Dana Sucha.